Welcome to CogX 2020. How exciting to have so much opportunity to hear thought leaders and debate about how technology can help us into our digital future. We are so excited this morning to be at the Industry 4.0 and Sustainable Supply Chains programming stage, one of 28 or more. And I'm very pleased to be able to introduce the subject of how our global supply chains are both intertwined and international, and how can tech help us make that supply chain more resilient. So to talk to us this morning, I'm very pleased to introduce Louis Derard and Simone Larson.
Hi, Jackie. Thanks for having me here. It's my first virtual event, so quite excited to be part of it. And I'll be presenting on machine learning platforms. So I think that the actual session title was a little bit longer, but on my slideshow it just says machine learning platforms. Let me just share my screen. And while I do that, maybe a couple of things I should say about myself, just to give a little bit of context. So I work as an independent machine learning consultant, and I also founded a series of conferences focused on real-world machine learning applications. So that was, I think that was back in 2014. So probably it wasn't that big a thing back then. But the objective was to sort of discuss lessons learned from developing intelligent applications. That was before people would use AI over the place. So lessons learned, but also discuss techniques and tools that allow us to develop those intelligent applications in a better way. And now you would refer to, so I guess the main category of such tools would be machine learning platforms. And we ended up, when I'm saying we, I mean the peace conferences ended up collaborating with Digital Catapult on a report on machine learning platforms. So just selecting my screen and then hoping that everyone can see, not this, but this. All right, so I'm going to assume that that everyone can see that that slideshow, hopefully. And right, so this is the report that we created with Digital Catapult and PPs on machine learning platforms. There's a lot of them. And I think that our main objective at first was to put some structure into everything that exists. So we've categorized those platforms in different types and subtypes. So I think that this presentation, I'm going to try to keep it relatively short so that we have enough time to cover questions and answers with Simone afterwards. And yeah, let me go over that, some of these examples also. So I tried to include examples. That should be for about a 15 to 20 minutes presentation, and then back to Q&A. So this is, if there's any Halifax customers in the audience, there's this snap check functionality on the app that I found was quite interesting, because this obviously uses AI to recognize the handwritten information. And I thought, what would it take to re-implement that? So you'd need to scan the check itself and get a proper picture like this. Right? That's something that most scanning apps can do on smartphones. So nothing too novel here. But also you need to be able to transform that handwritten text into text that a computer can read. And so I tried this service called Azure Ink Recognizer, I think it's called. So that's part of Azure Cognitive Services. And right, so I just wrote that with my mouse, but it works pretty well, and it allows you to integrate those sorts of features into your own app. And this is AI, right? But the thing is that this is a fixed sort of AI model that's been trained already with examples of handwritten text, right, from pictures, and then giving the machine the actual pictures, the scans, and the text to be extracted from that. And then a model's being trained, and then what we do here is just apply that pre-trained model, right? We don't have to train it ourselves. So that's one way that you can use AI in your company, in your product, and so on. And I guess, right, those platforms such as Microsoft Azure here is super easy. This is another example from a platform that's called Landing.ai in the manufacturing industry. And the idea here is to detect defects on this board and that's being manufactured. And then this is a screenshot from the interface where you're just labeling data. So most of the building of the model, of the model that will predict if there's a defect on your product or not, based on a picture taken by a camera. Most of the work is just getting examples and then annotating them. So here the annotation is appears in red, right? So you're trying to show the machine where the defect is. And then based on that, it will build a model, and then that model allows you to inspect everything that you manufacture in a super quick way. So this is what I would call a vertical platform, because it's a platform that allows you to create your own machine learning models, but for one specific use case in one specific industry, specific vertical. The other example I've got is a service that's called Science. So that's a picture I took in New York City in 2016. It was quite interesting to me to see that they would advertise a machine learning product in the streets, this huge billboard, and then it says, maybe I can zoom in a bit, quite fraud with machine learning. So yeah, Science is a service to make it easier to detect fraudulent activity on your website, such as fraudulent news. And this sort of makes the thing that machine learning is for everyone if it's being advertised in the streets. This is a screenshot that I downloaded, a screenshot of Science. I haven't used the product myself, but it's quite funny that so this is made up, obviously, Voldemort@gmail.com, and then a blog user, Harry. Right, so this is made up, but the idea is that it allows you to, it comes with a dashboard that allows you to have an overview of what's going on. This is another screenshot where what's interesting is that, so any activity, such as a payment, is going to be scored against a predictive model that would say whether there's a high risk or not of this payment being fraudulent. And then if you let the transaction through, and if you end up realizing the bank notifies you that this payment failed, this was a fraudulent payment, then all that you need to do is to pass information on to the Science platform. So just telling it, all right, this transaction with these characteristics, this amount, this IP address, and so on. Eventually, that didn't happen, right? We didn't get money, so that should have been detected as fraud. So please learn from that data, from that new data point. And what's interesting with this interface is that we get to see why a specific transaction would be classified as suspicious. Here it says top suspicious signals. So making it easier to integrate machine learning into what you do, and then this is creating a model that's specific to your data, because you would be sending the information that this payment was okay, this payment was not okay, and then it learns from that. I've talked about the pre-trained models, sort of pre-trained models as a service type of platform. I've talked about vertical platforms. You have model development platforms, so machine learning model development platforms that are more flexible. So starting with what I would call the semi-specialized, because they're not as specialized as the vertical ones, but they would be focused on one type of machine learning problem and on one type of input to the problem. For instance, image classification. So the input that you have would be an image. It would have to be an image, and then you could classify it in however you want. So your task would be providing the data again. The great example of that with this platform called globalisation that was acquired by Microsoft last year, where you would examples. So this is trying to detect from a picture the mole whether it's benign or malignant. And I don't know if I can zoom in. It's hard for me to zoom in this presentation mode, but what you see in the bottom is a bunch of examples of moles, and then each one of them is labeled. It's labeled as benign or malignant. So you provide that, and then here, what is on the screenshot is that there were more than 1,000 examples provided, and then reaching an accuracy of 80%. And if you want, you can see those different blocks that are being connected to each other. There's one that says detect features, one that says generate labels. These can actually be customized, and you can click and go down into a deeper level of detail. And if you're able to program machine learning models, well, there's a lot of customization that's possible via that interface. So it's quite an interesting product. Here demonstrated on image input. You've also got the high level, what I would call the high level platforms as a service. High level because they're much easier to use than coding with machine learning libraries. There's additional functionality that's provided, and everything provided as a service, so you don't have to install anything. And sometimes those high-level platforms as a service, they come with sort of a web-based studio, a web-based interface that allows you to experiment with machine learning in any. And I've got a few screenshots to demonstrate that. But you also have those other types of studios that you have to install yourself. So self-hosted studio, maybe that requires a little bit more IT expertise. You need someone to install that. And you can't install that on any kind of machine, so maybe a little bit harder to use, but still it makes the job of creating machine learning models as easy as possible. And then in the end, you've got the IDE, so integrated development environments. Basically, what this means is that you write code. So in development environments that you can write code, machine learning code, in any way it run on the cloud compute. So let me do some screenshots. So this is from going back to the high-level platforms as a service. This is from a service that's called BigML. And let me see if I can use the laser pointer. Right. So all that to specify what is the thing you try to produce. So it could be debate anything, collect data about real estate, seeing what's on the market. And getting information about real estate properties, and then the thing that you predict would be the price. So you've got your data, you've got your spreadsheet data, and you point to the column that contains the information you're trying to predict, for instance, price, then specifying how much time is available to optimize the model based on the training data. And then if there's an advanced configuration where you specify some optimization option, or you can just through the menus without customizing anything, it would build a sort of baseline model. And those baseline models are quite performant. They use animated machine learning technology, and in practice, it seems that these things work well in most industries. There's also the ability to customize the model that's being created. So here, a neural network model, show option, not to comment on all of them. Basically, you've got more settings if you want. You can customize these things, and it's interesting that this requires machine learning knowledge, so you have to know what it means, what value means, those sorts of things, but you don't have to code, right? And once you've created models, it's very easy to create models, and then immediately you get to see sort of a dashboard that shows the model performance in various ways. So what's interesting to see with these tools is that it brings the focus to the evaluation of the models rather than the creation of these. I think that's probably the most important thing to think about when doing machine learning, when starting a new machine learning project, is to think about how to evaluate a model more than thinking about which algorithms to use. This is a screenshot from Microsoft Azure Machine Learning. So this is they also have an automated machine learning tool that's similar to what you would see that we saw with Big ML in the previous screenshots. But you also have this designer environment that's being shown here, where you can customize the creation of the model a little bit further, and then you see that it's a bunch of that further, starting with at the top with training data, and then in the end you get a machine learning model. This is a screenshot from a self-hosted studio called Dataiku. The actual name of the product is Dataiku Data Science Studio. So you see here, I think it's the classic machine learning data set called the Titan data set, because it records has the information on the Titanic passengers and who survived and who didn't survive. So the idea is to build a model that allows you to predict based on information of those passengers if they were likely to survive or not. So you've got this survived column, and then it's very easy also to create automated learning models with this studio. You just click on the column, on the survived column, and then you click on create prediction model, and then you make where you say please automate everything and create the best model possible, and then it does that. And this is showing a environment, so an IDE, a cloud-based IDE. The service is called Floyd. So yeah, that all code. Just a quick recap of the different types of platforms. So I presented them from pre-trained platform, pre-trained service platform to model development. So I'm going to go the other way now, starting with model development and deployment platform. So if you fix the domain of application, type of inputs you want to do with, types of inputs and outputs of the machine learning problems that you want to deal with, then you get to call a semi-specialized platform. And then if you fix the prediction problem, such as predicting churn or predicting fraud, then you end up with a vertical platform. And the vertical platform still allows you to provide your own input-output data. If you feed input data, then you can create a machine learning model, and then you've got this pre-trained model that might be useful to other people. So it depends. Like a company's churn prediction model might not be useful to another company. Doesn't make sense. But if I build, for instance, a sentiment analysis model, then sentiment analysis really means the same thing for my company and for your company. So maybe it makes sense for me to try to offer that as a service. And right, I had some. So this is in the report. You can download that from. I think there's a link on Digital Catapult website. This is the link to my own website. It's easy for me to remember. So louisdorard.com/platforms. Again, this was supported by Pepys and Digital Catapult. So I think that this is it for me, and we can just go back to. All right, just stop sharing my screen. And now I'm going to be joined by Simone Larson, who's head of AI and machine learning commercial product at Digital Catapult. And Simone focuses on accelerating adoption of advanced digital technologies in manufacturing and creative sectors. Hi, Simone.
Hi, Louis. Good morning. Thanks for having me. Thanks for the introduction, and hello to everyone who's also joining this live stream. As Louis mentioned, this is also my first virtual event. I'm quite excited. Interesting presentation, Louis. Quite fascinated about the different platforms that are available for companies to accelerate the adoption of machine learning algorithms. I think let's just start off with some questions. If you take it from a high level, what are your recommendations for picking a platform, if any?
Right. That's a big one. Got a few, but it's difficult to know where to start. My recommendations would be to so I'm try to structure my answer. I think that it's important to first of all, go beyond the marketing material that's on those platforms, websites, and so on, and go straight to looking at the documentation and then trying it out. It's yeah, maybe it's just too simple an answer, but I think it's important to try to just see what's the best fit for you. Those platforms, they have target different types of end users. Some of them be specifically targeting developers. Others would be specifically targeting scientists. Maybe others would be more accessible to domain application experts. And I think that for those platforms that have a big focus on providing a nice interface, providing nice visualizations of the machine learning model, the performance of the model, and so on, that probably is aimed towards the domain application experts. So I think that it's important to figure out who is this platform for. I think that a lot of people I get this question also, which is the best platform to use quite often. And I think that there's this misconception that different platforms will have different, they would provide models of different levels of quality. I think that they're equivalent. The quality of the machine learning models that you create with these platforms is quite equivalent. So I think that it's really a matter of picking something that's easy to use. I think that when you're entering that world of machine learning platforms, some of them can be quite complex to use, and I think that the objective with machine learning is something that people lose track of, is that it's important to experiment and to iterate and to get this tight feedback loop. So you want to start with something that's as easy to use as possible, something that gets the job done in the quickest way possible. So I usually recommend people to try to start with the high-level platforms as a service as a first step. But sometimes, they say that it's not possible because everything has to be on premise. So, you need to have a look at whether it's possible or not to run that platform on premise. And I think that more and more of these platform vendors are trying to provide that option. You would want also to look at, so you're going to build machine learning models, but obviously you want to avoid being locked in to a particular platform. So, what are your options for exporting your work? And I think that the first thing that comes to mind is, how can I export the models that I'm creating with the platform? So there's different formats that allow you to export models. So you probably want to check what is possible. I think that also I'm seeing that those platforms become more flexible in terms of exporting and importing models. So it's actually possible to mix and match. Maybe you're going to develop your model using Microsoft Azure because you prefer the interface and there's more automation. And then maybe in the end, the model, you export it and then you have it run on Amazon Web Services. That's an option. But also you want to think about exporting the whole workflow that leads up to that machine learning model. So what are the export formats? That would be another thing to think about.
On a similar point, so obviously there are some recommendations for picking a platform, but before a company actually commits, right? So they've done their research and they're trying to hone in on which platform is best for them. What are the top 3 things, in your opinion, or that they should definitely prioritize when it comes to committing?
Right. I think it's pricing is going to be, it's definitely going to be a big factor, a big thing to look at before committing. And it's interesting to see that the pricing models can be very, very different from one platform to another. So some of them would have a fixed annual license that could be quite costly. And if you're just starting out with trying to execute a pilot project, a pilot machine learning project, maybe you don't want to use some of these platforms with this huge yearly cost. It doesn't make sense at first. Maybe you want to start with a sort of pay-as-you-go platform, and then see where that takes you. Once you've executed that first pilot project, much more, and then maybe you have way more information to decide whether it makes sense to consider platform X or platform Y. You want to think about, so I mentioned the very high level platforms, the vertical platforms, the semi-specialized ones, and then the platforms as a service. I think that they are very valuable, but you might want to check who owns that model that you're creating. So what are the conditions? And I think that the platform like Sift makes it so much easier to detect fraudulent payments. But then before using something like this, you want to check who owns that model, and that relates to my point about exporting capabilities. Yeah, that would be. I think there's probably more that we touched on that also in the report. So I think that there's probably more in there, more recommendations, and also I think that we also provided a list of sort of questions to ask yourself before committing to a platform, and that can be as simple as is there a free tier to. It's difficult to pick the platform that is the most that is going to optimize the cost of running your machine learning infrastructure if you have a very precise vision of machine learning system. Is in order to be able to anticipate on the cost of these platforms, you need to know what is the volume of predictions that you need to make in a given period of time. And also the volume of models that need to be created. Are we talking about one model for all of my customers or all of my users, or one model per user? And do I need to refresh that every day, week, month? So having all these constraints in mind, and there's a framework to sort of help you think about all of that, which is called the machine learning canvas, and this is sort of the last bits that you would focus on, technical constraints on making predictions and building models. So it's sort of the last thing you think about when you envision a machine learning system, and then knowing that allows you to pick the platform also that would be the least costly.
Of course. One thing we come across quite often at the Catapult is the fact that within the industries that we focus on, the foundational elements to apply machine learning isn't there. So very little data. If it's there, it's fragmented. There's also a misconception of the problems machine learning can and can't solve. For the companies where they do have the data and they have a good idea about what machine learning can be applied to, so we've taken them on that journey. There's also very limited information from a company perspective about how to build a team, right? So let's just say they've done a proof of concept with us and they want to move to MVP, demonstrate, and scale. Coaching them on what a team would look like, whether it be an in-house bespoke algorithm or something that's as a service, It's quite an interesting discussion. So it'll be good if you can elaborate on how to build a team and the tools that are needed.
So I think that there's probably tons of exceptions to what I'm going to say, but sometimes I do this parallel with how things were in terms of web development a few years ago. I'm really bad in history. When it all started, you thought that you needed to have an HTML developer and a CSS developer, and then and it was the case, right? For any website that you needed to build, you needed to have that technical expertise. And nowadays, you've got tools that don't require any coding skills to create your website. I created my website without a single line of code. So I think that we're seeing the same thing with the same things going on with machine learning. We have these highly automated tools. They become more and more automated. So I think that now the sort of automation that's missing is in managing changes in data distribution and managing the fact that you need to sometimes refresh your model and so on. So that's not that automated yet, but creating a baseline model, there's a lot of automation here. And I think that, as you said, there's this difficulty of aligning what the business is interested in with the capabilities of machine learning. So I think that the first thing that you want to do is not think about how to use the best algorithms to get the most out of a machine learning model. The first thing you want to do is to just make sure that you can create an initial model, and then you can evaluate the performance of that model. I think that even before creating the model, so you need to know how it's going to be evaluated, and you need to know what level of performance is enough for deployment in production. And I see lots of teams get that wrong, and then focus on how can we build a team that knows how to create super advanced machine learning algorithms. I think that there's a metaphor that I quite like, which is that you want to open a restaurant, and you would be hiring someone who knows how to build an oven. And that's not what you want to do. You want to hire someone who knows how to use an oven, and someone who knows how to create a menu and then execute on a recipe. But they don't know. They don't need to know how to build that oven. So I think that this can be a big misconception. So this metaphor is actually not mine. It's from, I'm trying to remember her name. I'd like to quote that person. That'd be best. Sorry, I can't remember her name. Someone who's working at Google, I think, as a chief decision scientist or something like that. So that's not my metaphor, but I quite like it. And I think that in many cases, the expertise that you need, I think there's two very important things: that data engineering. This is always very important. Software engineering. I think that a lot of people lose track of the fact that we're building software. In the end, we're building software. So this requires software engineering. This requires data engineering, because that software is based on a model which is trained on data. So even though the whole building of the model could be automated, you need to present the right data to that AutoML functionality. So data engineering, super important. And then the skill that you need is also, I think that there can be a tendency to just say, all right, let's hire experts and leave it in their hands, and so they come up with. I think it's very important to upskill everyone in managing. So from project managers to CEO. Because you need those people in order to make the most in order to make profit from machine learning. I want to say to make something useful that's going to solve someone's pain, and that could be either making the company more efficient, but that could also be making the company's customers more efficient, solving their pains using machine learning. So you need you need to, if you want to get that alignment between the capabilities of machine learning and business usage, this also requires that the more business people be skilled in, or that they understand some of the concepts of machine learning.
Machine learning, of course, obviously, buy-in from the top down is a great facilitator of success and investment in these advanced digital technology projects.
It makes sense, but over and over again, you see people struggling with that and just trying to leave it in the hands of the experts and not owning the topic themselves.
Yeah, we struggle with that at the Catapult as well, because we may get a particular business unit that comes in and they want to experiment and innovate, but we always hit a wall when it comes to a successful proof of concept and growing it into something larger, because the executive level hadn't been bought in on the project, and there's been issues about seeing the ROI and why should they continue. But I definitely resonate with your point about getting as much senior stakeholder buy-in as possible.
That actually reminds me, one of the bespoke machine learning platforms that's probably the very well known is the one that's being used at Uber. It's called Michelangelo, and there's different sort of end users in mind for that platform. You've got developers who would be accessing predictions from existing models, for instance, estimated time of delivery of if it's an Uber Eats as a use case. But you would also have data scientists who would want to operationalize their model, but also they made a point to provide an interface for business types to understand what's going on with these machine learning experiments, and also to see to monitor performance live. So yeah, that's something to keep in mind. I guess it's good to have a way for domain experts and business types to access the platform and to see information that can be relevant for them.
Indeed. So you mentioned a point around teams getting it wrong. Sometimes, if not a lot of times. What are the common mistakes and conversely factors of success you have noticed and would like to chat about?
I think that it's kind of paradoxical, because one of the things that comes to mind right now is people spending too much time thinking about which is the best tool to use. And we did cover that in the machine learning platforms report, what is the right platform for your needs. But I think that, sometimes it's kind of like using that as a pretext to postpone doing the hard stuff, thinking about, it's probably nicer to use Azure than AWS, SageMaker, there's a nicer interface and so on. So spending too much time thinking about what are the right tools. I think that's so I spend quite a lot of time helping people come up with their first machine learning system, right? Creating their own machine learning system, and sometimes it's like the first time they're doing that, or other times it can be the second time. And I think that also relates to the point that you're making about aligning what machine learning can do with it's useful for the company. I think that oftentimes projects don't go through, they don't go beyond the proof of concept, because from the beginning it's not clear to decision makers that machine learning is a source of cost. So everything that people are thinking about is what the gains that are associated to machine learning, and obviously you need that to stay motivated. But the reality is that beyond the cost of running your machine learning system, so that could be the cost of the platform, using the platform, there's the cost of data acquisition. So underestimating the cost of acquiring data. One example that I quite like is in the banking sector. If you've been collecting data about who's repaid their loans and who hasn't, that data is biased, because the only data that you have is for people that were already approved by someone, by a human person. And if you want unbiased things, it means that you need for a certain number of people, you just need to say, okay, let's approve that credit application and see what happens. Obviously, that has a cost, right? If you do that too much, then pay for that. But so you want to find the right balance, right? So data acquisition has a cost. Unbiased data acquisition has a cost. But also, what's particular about machine learning, I was saying that in the end, we're building software. What's particular about machine learning is that this is software that always makes errors, and that's not something that we used to when we're building software. Right? We want to build error-free software, but machine learning models always make errors, always. So you need to quantify these errors. You need to know what is the cost of that type of error. So sometimes people speak of false positives and false negatives. Are two different types of errors in the classification setting. What is the cost of each? What is also the gain? You're hoping there's a gain. Maybe everything is framed as costs and cost reduction and so on, but there has to be a cost reduction or a gain somehow identifying, predicting correctly. So having these true positives and true negatives. So that sort of framework of having cost values, putting them in what we call a cost matrix that helps you navigate those sources of costs. And also, I think that one last thing that we would tend to underestimate when thinking how to transform a company with AI or with machine learning is the cost of changing people's workflows. Because in the end, if you want your machine learning system to be useful, it has to be integrated into your end users' workflow. And so it means that you're changing that person's work. I think that can be a big problem in the manufacturing industries, or in some industries that can be a bigger problem than in others.
Indeed.
But I agree also with, I didn't comment too much on the amount of data that's required. I think that in general, it's just keeping things simple. I think that people underestimate the importance of working on data. So it's starting to, the message of, data transformation is important, starting to be integrated by more and more people. But I think that also it's very important to collect data and to invest money in collecting data. And not just it's not just data preparation that's important, it's data collection as well. So something to, and in the the other day I was realizing that most of the machine learning platforms don't provide out of the box ways to sort of plot learning curves. So a learning curve is something that shows you, with the amount of data increasing, has performance increasing. And this is, when you're starting out, this is something that's super important, because initially, it grows like this, performance grows like this, and that point is going to hit a plateau. But then you need to sort of know, before you invest in data collection, you need to know if you've already hit that plateau or not. If you've hit the plateau, maybe it doesn't make sense to invest that much in data collection. But if the trend is like this, then probably it suggests that if you had twice as much data, then you'd be here in terms of performance. So yeah,
Okay.
Requires experimentation.
Of course it does. Thank you so much. We are about to close this initial part of the session, and I'm going to hand it back over to Jacqueline to take us through what the next session will look like.
Thank you.
Thank you very much, Louis and Simone, for a fascinating conversation around choosing machine learning platforms. It's not as straightforward as you might think. And one of the things I took away from that was that manufacturing companies will have to change their workflows if they want to get it right. You have to assess the cost of true gains and obviously of the true costs of good data. And how we ensure successful deployment. All of these very important questions can be further explored at the Q&A session, where you can meet the experts. Head over to your CogX Festival app, where you can navigate towards the Q&A. You can also check in and do some networking. Don't forget to also post on Twitter on the CogX 2020 hashtag, and then meet us back here at midday for the Sustainable Futures track, which is all about if you can track it, you can improve it, and how the Internet of Things offers hope in the climate of crisis. So how do we get this right in the next 10 years? This is what CogX 2020 is all about. See you back here shortly. Thank you for joining us. Welcome back to the Industry 4.0 and Sustainable Supply Chain stage. We are delighted that you have returned or perhaps just joined us. Hopefully you have headed over to the CogX Festival app for some networking and for the dedicated Q&A. This is all about how we get the next 10 years right. And now I am delighted to introduce the next session, which is Sustainable Futures. If you track it, you can improve it. How the Internet of Things offers hope in the climate crisis. And to do that, I am delighted to welcome David Pugh and his team to the stage. Thank you, David.
Thank you, Jacqueline. Good afternoon, everyone, and welcome to this panel discussion. So we'll be discussing how advanced digital technologies drive the UK's net zero ambitions and how we can embed sustainable practices into business. And to join me today, we have Angela from Tilugai.
Hello, David.
And Simon from Arup joining today.
Hello.
And just to kick us off, would you be able to just give a 2 minutes overview of who you are, the organisations that you represent, and how your companies are looking at sustainability and why you joined us today? We'll start with you. Yeah. Oh, sorry, Angela.
Yes, my name is Angela Angulo. I'm representing here my dual role as the director of the Renewable Energy Innovation Center with Bedfordshire University and my innovation consultancy manager role at TWI. My background is in industrial and electrical engineering and structural integrity, which is what I've been basically doing at TWI for the last 7 years. This is highly related with the topic of today because it's using sensors, data, and software to ensure the suitability of assets, engineering assets, to perform their right function. So yeah, this is me.
Great, and so I'm Simon Evans. I'm the digital energy leader from Arup, which means I look after how we can use advanced digital technologies to enhance our engineering design, delivery and operations, particularly in the energy sector. So my background, I'm a chartered engineer and a technology developer with a background in the heavy industries, which is things like oil and gas. And I've got a particular passion for how we can use the transformational applications of digital engineering, and in particular the concept of a digital twin in society and in industry. So further to that, I'm a fellow of the Institution of Mechanical Engineers, really actively involved in the institution. And the final thing I'll say is that I'm the delivery team lead for the Centre for Digital World Britain and their National Digital Twin Programme, which is a programme, if you've heard of it, that's creating the language and framework to create an ecosystem of connected digital twins for the entire UK. In terms of sustainability, so for Arup, it's a core part of our offering and one of the key pillars of our strategy and our ambition to shape a better world.
Brilliant, thanks both. And my name is David Pugh. I'm the Manufacturing Partnerships Lead at the Digital Catapult. So my job is to sit between industry and advanced digital technologies and ensure that advanced digital technologies are used responsibly and safely to ensure sustainability, optimization and improvement in industry today. So to start off our panel, one of the last things that Theresa May did as Prime Minister was ingrain some important targets to produce net zero emissions by 2050. Now, this is a long way away. It's 30 years away. But why is it important for organisations to start acting now to achieve these goals? And I'd like to start with you, Simon, on that one.
So it's a great question. And I think the key part of this is that in order to achieve 2050 goals, you have to really start today, because it's not something you can click your fingers and just do overnight. There has to be a plan, has to be ramped up slowly, there has to be the right market incentives. So for organizations such as ourselves and such as industry, it's imperative that we make the choices today that will put us on the roadmap to get to that destination in 2050. And be that you put aside the right investment or you make the right decisions around future works you're going to do. I think it's a core part that we really have to consider.
And how?
I think it is important that we start working on it now, and I'm aware that there are many business and companies, universities that are looking at this already. So we have been working on developing new models of collaboration in the last few years, but maybe more than 10 years. But the interest of first universities that they have shown in renewable areas, in decarbonization, in sustainability has increased a lot, especially in the last 6 months to a year. We have launched 3 different innovation centers between TWI and different universities in UK. One in renewable energy, another one decarbonizing industry, another one in circular economy, which is another aspect as well. And the last one was actually between Digital Catapult and TWI, which is a Cambridge-based industrial net zero innovation center, aiming to support business and companies to get there to reach that horizon in 2050 that all the players are trying to get, and the sooner we are there, the better, because we have to take the opportunity and we have to make sure that all the players in the supply chain are well represented and are very committed from the beginning to end. And this includes also the academia side, the universities, the research institutes, small companies, medium, large, any organization, because sharing facilities and knowledge is a key to reach that target that we have.
Absolutely. Sorry, Simon.
I was going to also say, I think a big part of it as well, isn't it, around the net zero emissions is hugely about the energy transition and what are all organizations and society going to do around that, and how we're going to shift from or away from, let's say, the dirtier fuels towards the clean fuels. I know some of that, particularly if we look at things like migrating to hydrogen, for example, a huge amount of effort and work has to be put in place between now and needing to do that implemented and effective by 2050.
Absolutely, that's a key factor in the success of our net zero transition. And it's really great to see, Angela, that there are lots of different organizations now coming together. We know that sustainability and climate action is not something that one organization could do. Would you just be able to expand on some of the centers you mentioned and the roles that they'll be playing and what your kind of hopes are for these centers and how they will be able to kind of drive innovation in this area?
Yeah. Well, the aim is that every center will have their own scope, and we are there to support research, of course, but also companies that are part of these partnerships. So we like to say is collaborate to innovate. In this case, is innovate to accelerate as well, to progress companies to reach certain levels. We have to make sure that from the very beginning, all the developments are designed with a view to the future in terms of design and materials and reuse of materials as well. So what we try through the innovation consultancy is to help to link people and to help companies to realize how important it is for them to be alert now, to be able to be ready for the future. So what we like doing as well is getting them to work together. There are different areas in digital technologies. We have to make sure we are able to measure impact and to, after defining the roles of each player, but all of them should be there together to be able to achieve that goal. Then in terms of the model of collaboration, really is we are some sort of a hub where different companies can come together, and if we are able to distribute them through the right channels, it can be the recycling and circular economy, it can be the decarbonizing, net zero, any specific area that those companies, small, medium, large, can go through, we will be there to help them to achieve those and to provide guidance, because some universities maybe very academic sometimes. Some other bodies like Digital Catapult are there also performing a similar function to link people to be aware of the market. And then from TWI, we come with the more industrial side to understand what are the problems of our members in any industry, in oil and gas, in transport, because this is something global really that applies to others. And we have to make sure that all the chain is linked together.
That's fantastic. It's really fantastic to see. So this panel, we'll be talking about IoT, and one of the most interesting technologies that IoT underpins is a digital twin. There's lots of potential here for how these can really change the way we do business, but also how we can achieve sustainability. And so to start, Simon, would you be able to just explain to us what a digital twin is?
Now that's the $1 million question, isn't it?
Absolutely.
So it's a great one because, yeah, digital twins, they mean many things to many people. I think most people probably see them as a product or a technology that you can just buy off the shelf and implement. But I think it's probably more helpful to us to consider it as a methodology and a way of working. And what I mean by that is if you look at the definition of a digital twin, and there's many across industry, but the one I'll go back to is the one that's put out there by the Centre for Digital Britain, who are of course leading on the National Digital Twin Programme, which I'll explain in a second. And that is really that a digital twin is some type of digital representation of an asset, a process or system within the built or natural environment at a level of detail or accuracy proportionate to what you're trying to achieve and to the use cases defined by it. Now, what that means really is that you have some type of digital or physical asset, let's say, then you have some type of digital representation of that asset. Now, the important part being the connection between the physical and digital, data flowing from physical to digital, where insights and decisions can be made. And then those decisions allow you to make interventions, if you will, back into the physical environment. And that connection, often seen as needing something like IoT, is actually just any type of connection that connects the physical and digital worlds together. So that's the kind of broader definition. Most people see it as a product that you'd kind of get off the shelf. But what I mean by considering it as a methodology, it's really about considering full life cycle information and data management across the entire asset. And how if you have that information in play from the beginning of when the asset was created all the way through to decommissioning, you can allow all these things everyone talks about to be achieved from the back of it. So that's the kind of the starting piece. But the thing I'll add on top of that is, of course, most of us, when we talk about digital twins, think they're new, particularly in the built environments, and which is many of the attendees of this event. But in reality, they've been around since probably about the 1960s. The earliest example being the Apollo 13 missions, where they called it digital mirroring at the time, and then into the oil and gas and manufacturing and oil and gas industries, probably somewhere in the last decade or so, and find the built environment. But the final thing I'll say that's really exciting is that, of course, a digital twin is great in isolation. You know, everyone loves that. But when it really gets exciting is when you start connecting multiple digital twins together into an ecosystem. And that ecosystem allows the communication of information between multiple twins, between multiple asset owners, and therefore the aggregated benefits that can be achieved from that is vastly greater. And that, of course, is the aspiration of the National Digital Twin Programme, to create that language and infrastructure to enable that.
That's really fascinating. Thank you so much. So I'd like to talk a bit more about the methodologies and principles behind the digital twin and how these can impact sustainability. And obviously, this isn't a new technology, but we're maybe seeing it more and more in new environments and in new industries. So how can industry use these methodologies and principles to impact sustainability? We'll start with you, Simon, and then go to Angela.
Of course. So I think you're right there that we're seeing an emergence of this primarily because of storage and compute, and of course connectivity has meant you can bring the physical and the digital worlds closer together. Now, how I like kind of conceptualizing a twin and then leading on to talking about how it can impact sustainability is that it's kind of this roof of a house, if you will, that is an all-encompassing kind of concept, and the walls of the house that support the roof are technologies such as AR, VR, IoT, BIM or information management. Some are important, like cornerstones, you need them, others are optional, but they all fit into this roof of a digital twin. Now, what that means is that by having this information and data management throughout the life cycle, the principles of what we refer to as a digital twin approach, it arguably allows you to make better decisions that are data driven. So you can understand the asset greater because you have more information about it, but you can also understand and simulate what if questions against your assets. So you have, let's say, a city. You can, if you have, let's say, this fully established twin, which is connected between the physical and the digital, it allows you to ask the asset a question: what if I did this or that? How would this change that parameter? And then allow you to make decisions that you can then enact and make effects back into your physical world. So why that's important is, on the drive for sustainability, there's a huge amount of information and a huge amount of data associated with it, a huge amount of things we need to consider, and we don't necessarily know how one situational scenario will affect a given course or how it will impact other items in the system. So by combining them all together into this kind of broader ecosystem or systems of thinking approach, it allows you intrinsically to have much more knowledge and informed decisions, as I say, when you go about it.
That's really fascinating. And Angela, how can some of the methodologies and principles that you've experienced in digital twins impact sustainability, and how can they be used to improve how we work in our daily lives?
Well, I have been looking at the digital twin technology for some years now, because this closely links to the approach of predictive maintenance, which is really something that I've been doing, looking at extending life of assets. And there are three major points, which are reduce power consumption and improve the use of resources and increase efficiency, and also increase the life cycle of any asset or product, and so on. But the main aim of predictive maintenance as a tool is really to reduce a failure, to improve the availability of resources as they should work, and to be able to prevent, to then take the right actions before further damage happens. So this is a bit what I mentioned at the beginning, the structural integrity side that brings data from different sensor sources. It can be structural, it can be operational in terms of temperature. Any sensing feedback is really an input for us to be able to identify how something is performing. I may be a bit biased towards the engineering side and big assets, but it can really be any others that link into smart cities, to day-to-day life usage. Basically, that's it.
That's really cool. And so we've spoken a little bit about how networks of digital twins can enable a digital system that is a network of networks. And what are some of the challenges in doing that, as well as the benefits? So obviously there's a bit of difficulty getting organizations to share data, but if you're able to overcome those steps, what can really be achieved?
A huge amount is I guess the answer, isn't it? If we compare that to, let's say, a mobile phone or computer, having a single mobile phone might be exciting, or a single computer, it might be exciting, you can do a lot of stuff on it. But when you start connecting multiple computers together into a network, and similarly to phones together so you can communicate between multiple parties, the actual benefits that come from it to society are massive. Of course, I'm kind of grossly oversimplifying how the phone system and the internet works in that statement. But in essence, if you look at how you might want to do that for connecting assets together, both in a localized context within one asset owner, so their portfolio, or also across a wider area or for an entire country, the benefits that can come from it are of that aggregated nature. So you often see when you hear people refer to the National Digital Twin Programme, it's often cited that it's very similar in importance, or as important for society, shall I say, as similar conversations that were happening 30 years ago or so when Tim Berners-Lee and his team standardized the internet, and of course the social and economic ramifications that came from that. So for me, I think the really interesting thing is exactly as Angel just said then, that when you connect these assets together and you can start to communicate and understand what each one's doing with each other, how they interact with each other, and what that means at a kind of a micro but also a macro level, it allows you to, of course, strive towards achieving such things as our ambitions of net zero by 2050.
Absolutely. And Angela, I know you've done lots of work in this sector, and as I mentioned earlier, we've had some of the first digital twins were things like spacecraft and oil and gas. But what are some of the new applications of digital twins? How are they being utilized in kind of emerging industries, and how are they able to adopt these to benefit sustainability?
Yeah, I've been lucky enough to work in a project developing a digital twin for wind turbines. So the fact there is that coming from a purely engineering side, traditional sensing devices that move into connectivity, data transmission and management, if we use all that information together with a simulation of the assets generally, being able to do predictions and life estimation using decision support tools, we will be able to get a much complete solution. So merging real-time data and simulations, we have developed intelligent solutions to first know how that asset, in this case a wind turbine, is operating at all the time, at any time during its life, but also to predict how it will behave in a certain period of time. But most importantly, it links a bit with what was just mentioned, is that if we are able to interconnect, let's say, a wind farm with different wind turbines, we will have more data, and we will also be able to predict failure in similar conditions. So if there is an asset that fails because of a given reason, it may be that we expect failure in consecutive assets at some point. So really, this is a powerful tool to ensure that we use the energy efficiently, and that we are able to generate as much as we can with the lowest impact to the economical side, and also the generation of CO2. Because really all the tools that we are implementing are there to somehow remove the human interaction, because sometimes these are difficult to access locations, and for operators or inspectors to get to the place in particular, lots of things have to be moved around, and in transport and time. So that all has a negative impact in the operation and in the efficiency of the management of those fields or farms or whatever we are monitoring in this case. And it's a great tool to be able to remove some of these uncertainties.
I think offshore wind is a really interesting space for it as well, of course, because we saw that market's really been created over the last decade or so and become much more affluent and buoyant, and a big part of our energy mix, if you will. And when it comes to an industry being so young as well, relatively young compared to the rest of the energy sector, it really creates an opportunity for us to do a lot more with the information and data associated with it. Because what we see in, let's say, oil and gas or nuclear is, if you wanted to do anything intelligent and understand an asset's criticality or asset's change through time, let's say its status or its health or condition, you'd need to have some kind of reflection on its historic information, which in more established parts of the generating spectrum, we don't have that information available, or we don't have the sensors. And going back to, I guess, part of this topic on IoT, we don't have that level of information available for the asset. But if we look at offshore wind, we know that they are heavily censored, particularly from the OEMs who make the turbines themselves, and they are monitoring every asset of it. And just through a software update alone, they can really rapidly or increase by a couple of percentage points the generating capacity of a farm, which is fascinating. So it just shows that this kind of feedback loop of monitor, understand how that impacts the design life of the foundation itself, which is what Arup are doing a lot of work in, and then justify the extension of that life, but also then understand how in reality this is functioning, and therefore adapt and tweak the asset so it can respond better to generate more, to get more, especially in a green energy context, is a really fascinating way of using this technology.
Absolutely, and we've mentioned there as well how you could have a fleet of wind turbines that can connect to a connected ecosystem. But what other examples of connected ecosystems are out there that are utilizing this technology?
I guess one of the cruder examples might be, or the simpler examples, is something like Citymapper or Google Maps, where if you look at that, actually the amount of data sets that aggregates is quite substantial, and the consumer experience that you get as an individual is great. You can navigate from A to B via C really seamlessly, but into the hood, the amount of information that's connecting up, be it bus from DFL if you're in London, or cellular data and people's movements, to allow that to be done is kind of maybe a low-level example of this connected ecosystem. But the intent, I think, is key. Is often when we talk about digital twin, a lot of people will probably spit and be like, oh, I hate that concept, that word. It's such a platitude or buzzword. And I think that's quite right, because most people probably focus on the unicorn of what a twin can achieve. This fully autonomous asset that's, can do everything itself, which is absolutely fantastic, like you'd see on Minority Report or something. But in reality, no one can just jump to that straight away. It's a journey, not just a destination. And that journey is about incremental steps of value, of proving a use case, proving the benefit that can come from it, and then moving on to the next step. And I think that's a really important thing that we've kind of touched on here, but to really iterate that we shouldn't talk about twins in industry as this aspiration, as that unicorn, because that's unhelpful. That clouds the water. We should instead be focusing on that first use case and proving it. And more importantly, really looking at, I'd probably use the term here, collaborating on the rules, but competing on the game. Now, what I mean by that is even the definition of a twin, if I Googled that, there'd probably be 1,500 or N+1 definitions. Each one says the same word in a slightly different order because everyone wants to put their own spin on it, which is fantastic, but actually that's unhelpful. That's not achieving any benefit to society or the economy, or even helping us achieve net zero at all. So what we should do instead is collaborate on the rules, by which I mean agree on some of the common terms, but then compete on the game as our own companies and how we can benefit and our USPs individually.
No, that's really fascinating, and it's definitely a good point that when you go to trade shows, well, back when we could go to trade shows, we'd see kind of huge banners on digital twins, and we'd see kind of this is what the future looks like. But actually, it doesn't have to be that complicated. You can make really positive steps just by taking the data you have and starting to work with that and understand how it's beneficial. And so I have we mentioned wind turbines, and that's obviously a very interesting area, and it's one that's kind of grown over the past decade. And as we've seen this kind of influx of new technologies, not just digital twins, but we've seen AI, we've seen IoT, we've seen lots of different technologies that are building into this. But what would be your advice to someone who is looking at this for the first time and saying, I've got some industrial assets. I want to start collecting this data to extend the life of my assets to be more sustainable. What would be your advice to them?
I think it links a bit with what Simon was just mentioning. Some people may be a bit scared or skeptic of the digital twin world because it's so big and broad that it's difficult to lock. So there are lots of steps in between that can be taken. First, we talk about many different words that are fancy. We have Industry 4.0, we have machine learning, AI, digital twin. There are lots of things happening around, but we have to be able to tailor each one for specific industry, asset, or development. So it is important to start with the instrumentation, the appropriate instrumentation of the asset. And something that has been mentioned before by Simon as well, I think, is that we ideally should be looking at historical data because that's very valuable information that we would have to start developing models. But if that's not the case, we have a new asset, let's say, we have to design it accordingly to the requirements of a future operation, let's say. So having sensors that are placed smartly and that are able to transmit the information that is required, it's very important. So that would be the first step on the way. Then the way data is transmitted, it's something very important to take into account initially. I remember discussing with Digital Catapult once about what's the best let's say data transmission tool or data protocol, and there is not really a single one. It will depend on each specific customer or company. Some of these assets are in difficult to access areas offshore or in explosive environments like many of the oil and gas ones. So that's let's say the next link between the physical sensors and the digital world that we want to complete. So selecting the right transmission protocol is important. Then the key here is how to use data, because there are two sides of the story here. Sometimes for us developing models, we don't have access to proper data information because that's at times a bit restrictive for other organizations. At the same time, big companies with lots of sensors, data and information don't know what to do with it. So there are big databases sitting there waiting for someone to use it. And the final aim of this is not just to gather data for the sake of it is to be able to have the right information, to filter whatever is not necessary, and to extract those parameters which will be given as details to improve the performance of the assets and to increase the life, to also feed into the inspection protocols, to define what is the maintenance strategy of a company. So that's really what we want to see at the end. One simple single tool that operators can use to predict their operations, to be able to improve the way they manage the asset, and not only lots of data and information that is flying around. So that's I guess our work at the end of the day, to be able to condense that and to provide the input that each specific company would like to see.
That's really interesting. And people often have talked for the last 10 years about how data is the new oil. And of course, oil isn't really useful until you do something with it. And it's the same with data. You can produce tons of data, but until you actually kind of processed it efficiently and you've applied the correct algorithms and the correct formula to it, it's not something that's really useful. And that's something I always try and get this people. It's made people quite possessive of data and say, oh, if it's the new oil, it must be valuable, therefore it's mine and no one can have it. But you're right, sharing data is as important to actually get that value. And so one thing I want to talk about, as we focused on kind of how we can apply it to existing systems, but if we're developing new systems now, we need to use these approaches to ensure that they're really valuable. And so especially with the work you're doing for the Centre for Digital Built Britain, how people that are building new things now, be that individual assets or new factories or new hospitals, what advice would you give them on how they can use these techniques to really benefit, not just in sustainability, but in all aspects of their operation?
Absolutely. And I think I'd first add on your comment there of data's the new oil. I'll add to that and say maybe it's the new asbestos that we think is fantastic, but in the future we'll realise maybe something else about it. So yeah, to your question on how can what should we do on the new build assets and what should we be considering today? So I think a key part is that obviously the technology horizon is moving very fast. Things are emerging and coming out all the time. And if we are starting a new build project today or instigating a project, we should be considering the concepts of a digital twin approach. And again, I'm using the word approach there intentionally, which is that full life cycle and information management, everything comes from that. Because if we're not doing that, then in essence, we're creating a dumb asset for the future. And that's not really helpful for anyone, because then we'll have to do retrofit and that's expensive. So the key recommendation I'd say for anyone in this space is to consider it today, consider it right now and what you need to do, because we often see that's value engineered out of a program, and that's again unhelpful. But consider at least the basic concepts of what you need to achieve for that first use case, but also have in mind the longer term horizon, that destination of where you want to get to. And secondly, align yourself with industry. It's, as I said before, about collaborate on the rules and compete on the game. It's not helpful for everyone to try and make their own versions of things because you don't have interoperability. And if we want to get aggregated benefits across society and the economy, we need to have that interoperability between different systems, different data sets, and therefore things like the National Digital Twin Programme, if you haven't seen it, I definitely recommend checking it out, are key to that. And on that particular piece, they have recently released a document called the Pathways document, which details how you go about physically implementing this Internet of Twins, or the twin infrastructure, as it might be referred. So that would be my recommendation. Consider it today, align with industry and collaborate, get out your silos, because in reality, every sector thinks they're special, but in reality, we have the same challenges and same problems we need to address. So work across sector, see how we can bring things from energy, my domain, into water, into the built environment in general.
Absolutely, that's really useful. Thank you for sharing that insight. If people are interested after, that's definitely a report to look up. So we've talked a lot about digital twins and how they can be used to benefit industry and to become more sustainable and to better understand what you're doing. But who are some of the trailblazers in sustainability that we should be following and understanding how they're doing things? And we've mentioned CityMapper, obviously, are using lots of data very well, the wind turbine industry, but are there any companies or specific industries that are really, really taking this seriously and really working hard, not just pledging to become net zero, but working hard to achieve these goals? And I'd like to start with you on that. Which industries or companies should we be kind of following the lead of?
Well, it is a bit difficult for me to talk about any company in particular. I will focus attention of those that are talking about digitalization, generally the digitalization of assets, industrial transformation, manufacturing as well, because those are companies that are committing to the future. So big companies will have their own programs to progress and to achieve their targets. Probably it's contradictory to mention the oil and gas sector in this case, but I'm aware that many of the oil and gas companies are now launching programs to reduce the oil consumption in a way, or at least to expand business to other areas, because we know things will change at some point soon. We're looking at 2050, but everybody has to be ready for that, and that's a big expression of interest, I would say, of these big players to be able to expand their portfolio to new disciplines like renewable energy, wind, solar, geothermal in a very heavily dominated oil environment.
Excellent. And Simon, same question.
Yeah, so I think it's again a really interesting question, and I think linking the topic of sustainability to decarbonisation in particular, there are quite a few companies out there and quite a few organisations and sectors that are really taking a drive on this. And for me, my background, of course, being in the energy sector, energy is a big part of the decarbonisation agenda. There's a big emphasis, particularly on some of the less clean fuel types to be, and we know are going to be turned off. And you have parts of energy transition, such as hydrogen, again, which we in Arup do quite a lot of work in, is a key part to that. So I'd say that if we look at the energy spectrum, the energy sector, they are a leading part in this because they have to be by necessity, because a lot of the emissions that we come from that are making us a lot of our emissions that are leading to us also needing to decarbonise are related to energy in some capacity or transport, let's say. And there's other megas, like I just mentioned there, some of the oil companies. So I know BP, to reference one, has made ambitions to be net zero by 2050. Now that's quite impressive because, of course, BP, known by many of us to be one of the large oil majors, and they're also now leading the way and probably have the capital in some capacity to help drive forward the decarbonisation and sustainability agenda. So as much as we can see ourselves distancing from some of these people, some of these more less clean fuels, some of those organisations are also really, really well positioned to help us achieve these ambitions in the future.
Absolutely. And yeah, decarbonisation is not something we can do in silos. It's something everyone has to do to really achieve. And on that, we've talked about technology, but technology isn't this catch-all kind of golden egg that will fix this. Technology has its own carbon footprints. So what do you think we can do to minimize these going forward as we integrate data and we build digital twins and we deploy more sensors? How can we minimize the environmental impact that technology has in these sectors?
And that's an interesting one, isn't it? Because was there a couple of years ago when Bitcoin was all the rage and everyone's really excited by it, there was that line around the amount of energy spent globally to mine Bitcoin was like equivalent to the usage of Iceland or something like that. I don't know the exact stat, but it was like a ridiculous amount of energy being used. So you're quite right. Technology, by definition, will be creating some type of environmental impact. But what we're also seeing at the same time is that as technology evolves, it is becoming more energy efficient at the same time. So we can see this, let's say, through a simple one of data centers, we know are very, very energy intensive. So for a long time, what have the providers of energy or data centers been doing? They've been locating them in cold climates, so you don't have to use as much heating. And the same with microprocessors. Of course, we know that they're becoming much more energy efficient. So you have this kind of semi-link where the more of them are appearing, you know, how many IoT devices are getting connected every day is millions. But equally, each of these IoT devices are becoming slightly more energy efficient. So we're both decarbonizing as a nation and introducing more technology, which is increasing our footprint, but this is then more it's more sustainable and has less emissions, so it's also at the same time balancing. So it's kind of like a bit of an act. We need to do more, of course, but I think that's an important consideration to have.
Absolutely. And Angela, in your work with renewable energy, how is renewable energy being used at things like data centers to improve their efficiency?
Well, the fact is that we have to look at more efficient processes. So there are conventional energies and now looking at, let's say, new materials, new processes, new way of generating electricity are becoming more and more important, because in answer to your previous question, I think we have to look at it from the design stage to select the right processes, the right materials, and that meet the scope really, because not only we need something that is gonna be fit for purpose, that is gonna do the job in a way, we have to make sure that the full cycle is integrated into this sustainability model.
Absolutely, thank you. But those are really interesting things. It's always useful to think about the system as a whole and how using technology is to solve problems, but also to solve those problems that technology then creates is really valuable. So just as obviously we are currently at a point where we're sadly not together, we are working from home, and we're starting to see industries get moving again. We're starting to see the economy hopefully recovering. There's obviously a need to ramp up production quickly, get the economy moving as quickly as possible. But how should industry be working now to ensure that progress that has been made in the last few years isn't lost, and that organizations can enable a green economic recovery and continue the good path that they were going down before COVID hit us? And Simon, we'll start with you.
By collaborating, I'd say, and that's an important part of it, because yeah, absolutely, we're in an interesting space now where we're not able to see each other, and we've seen many studies that have come out in this time that emissions have dropped, I think, in the UK to the lowest level since 2006 or something along those lines. So we have really positive step forwards because of this knee-jerk reaction to, of course, the current situation. And how do we come out that stronger? And how do we not just return back to what we were doing before and increase all our emissions as normal? I think that is a challenge that I don't know if we've fully worked out yet. But one that as industry and as society, we need to collaborate on and make sure that we do make the most of where we've got to. And incidentally, on your systems-based thinking approach, there was an article I read recently from the World Economics Forum that was referring to how the systems of thinking approach being led by organizations, again, such as the National Digital Twin Program, is key for the economic recovery post-COVID. So it's that systems of systems view, but also collaborating and making sure that we can really come out of this stronger. That's what I'd say.
Fantastic. And Angela, excuse me, Angela, what as we go back, how would you say companies should be working to ensure that they're still being sustainable, they're still able to introduce new programs of sustainability as we move forward?
Well, I couldn't agree more with Simon when he's mentioned we should collaborate together, because now we are aware of how some companies are going to struggle to just go through their normal day-to-day activities. That's why we are raising this question, really, how are we going to keep the motivation high? And we have seen many initiatives from the government. I understand the UK Research and Innovation body or defense body will try to support that, to support the new companies to innovate. And to get there. So yeah, we have to make sure that this is not something that stays aside, because there have been quite a few good things coming out of COVID, let's say, and we've seen how contamination levels are as low as ever. The generation of CO2 and others, driving, not needing to do so many things in a way to be more responsible with the environment. We should look at the positives always.
Absolutely. One of the great things about some of the technology spoken about today, it means that people don't have to necessarily be present in as big large numbers in a site. You can be sat in an office somewhere else or at home, observing what's going on and understanding what's going on and being able to bring that in. So we've just got a few minutes left. We will, of course, be back at 1 o'clock for a question and answer session. But I'd like to close off this session by asking essentially an answer to our first question is, what advice would you be giving to people who are either at the beginning of their sustainability journey within their organizations or looking at how they can become more sustainable? And what advice would you give them, and what sort of approaches would you tell them to take? And Heather, let's start with you on that one and see what people should be doing. I
think we have demonstrated that everybody in this area sector and innovation, especially in Industry 4.0 and digitalization, has to have a very holistic approach, and then be able to sit and assess the landscape and the business acumen of their investments, because what we have to be able is to guarantee that at the end of this process they will see not only benefits into the environment, but also a return on investment on the companies. So I think it is it is important that people is able to influence people in a way, but more from the side of motivation, and that there is something that is really there, and that we should be looking forward to it.
Really great. And Simon, same question.
I'd say 3 parts really. The first is start now. It's never too late or too early to start, and acknowledge that it's a journey and not a destination. That you have to have the destination in mind, of course, but there are steps of value along the route. The second would be collaborate. It's a problem that we're all facing, so let's work together on it and don't think that, let's say, in isolation we can solve it. And the third, we very much embrace technology, particularly now because COVID-19 in reality has become the first real driver for needing digital transformation. Many people talked about it before, many people wave their hands and say Industry 4.0, but until this happened in the rapid rollout of technology, we never really had that emphasis across all sectors. So really lean on that, embrace technology and take that forward as well. So I'd say start now, collaborate and embrace technology.
Brilliant. And that's a really great way to finish this first session. I'd like to thank both panelists for joining me this afternoon. We will be back at 1 o'clock for a question and answer session. But in the meantime, thank you for your time this afternoon, and hope you've enjoyed this informative discussion.
Thank you very much.
Thank you.
Welcome back to the Industry 4.0 and Sustainable Supply Chain stage. I hope you enjoyed this morning as much as I did. I am Kat Keeley. I'm CEO of Beep and founder of Frontline Live, and I'm going to be your MC for the next couple of days. So the next panel is called Graphene and 140, the dream ticket to boost Manchester manufacturing. It's a massive pleasure to hand you over to James Talentier, who is the communications manager from the University of Manchester. His panel will be talking about Materials 4.0 and how Manchester will set an example to the rest of the country about how the new normal can be better and faster. Over to James Talentier.
Hi, well, thank you, Kat. That's a brilliant introduction there. And welcome everyone to our session today. I think we've got some three excellent speakers today. I'll just quickly remind you guys who they are. So we have Jürgen Meyer. Well, actually, sorry, I'll start with Lisa, actually. Lisa Dale-Clough, Head of Industry Strategy at the Greater Manchester Combined Authority. Now, Greater Manchester is one of the few city regions to have its own local industry strategy, and it's Lisa's role to implement that. Then we have Jürgen Meyer, Chair of the Board for the Digital Catapult, UK's leading agency for early adoption of advanced digital technologies. Importantly for us in Manchester, is the champion of the Made Smarter initiative, which is bringing that program to bring digital technologies to the Northwest. And then my third panelist is James Baker, Chief Executive of Graphene at Manchester, and leading the commercialisation of the world's first 2D man-made material, graphene. And before that role, James was leading innovation in the defence industry. So, our format today is fairly straightforward. It's a panel discussion. I'll be asking a few questions to each of the panelists to keep the conversation rolling. In a minute or so, I'll ask each of the panelists to give themselves a chance to introduce themselves to you. But in the meantime, just remind ourselves why we're here today, and just go through the fact that, yes, as Kat said, our session is about Industry 4.0. It's about graphene. And it's about how that works together to make something very different in Manchester, but not just for us in Manchester. We think for the UK as a whole, it's a model that others can emulate. And I guess not many people probably know this, but Greater Manchester still has a big manufacturing base. It's still it's the birth of the original Industrial Revolution. So we still have a big textiles presence here, components making such as electronics. We also have tool making, and also a big sector around component making for bigger supply chains, probably serving the auto or the aerospace industries, etc. So how do we go about supporting, boosting that manufacturing base, particularly in the context of a post-COVID environment? Well, it looks like to us that Manchester is approaching this with quite a different viewpoint. It's bringing this kind of notion, its own version of, you might say, Materials 4.0. How does it do this? Well, taking advantage of advanced materials. About 16 years ago, in the University of Manchester, graphene was first isolated. As I mentioned earlier, that's the world's first two-dimensional man-made material. From that innovation comes some amazing capabilities, and already we're looking at that discovery as perhaps providing one of the major growth engines for the city region. Added to that is digital technology, and hoping to go digital, really taking advantage of the Made Smarter initiative I mentioned a few minutes ago, looking at digital tools such as the Internet of Materials. And maybe one final thing to touch on today is directing demand, and how we're pointing the region's manufacturers to the grand challenges, such as sustainability, green growth, etc. And how by adopting I4O and graphene, we want them to become market leaders, not followers. So if I may, can we start with Lisa and introduce yourself and say who you are and why you're here?
Thanks, James. So my name is Lisa Dale-Clough. I'm Head of Industrial Strategy in the Economy team of the Greater Manchester Combined Authority. Just as a way of context, Greater Manchester is a region of 2.8 million people in the northwest of England. Those people live in 10 different local authority areas. And for reference, our economy is larger than the economy of Wales. It's larger than the economy of Croatia, for example, just to put things in context. We've got 124,000 businesses in the city region and 1.3 million working adults. So our economic plan was set out in the Greater Manchester Local Industrial Strategy that we launched last year. And my role, as James said, is to coordinate the implementation of that strategy across a number of different areas. The strategy is a two-pronged plan, really. One part of the strategy is focused on how do we capitalise on Greater Manchester's global strengths, which include advanced materials and advanced manufacturing. They also include health innovation and the life sciences ecosystem in the city region as well. And then our fast-growing industries around digital, creative and media, and our aspirations around carbon neutrality. The plan also contains a number of actions to actually improve the foundations of the economy in the city region as well. So that is around improving the transport and physical and digital infrastructure of the city region. It's around knitting together our innovation ecosystem more thoroughly. And I think that's what a lot of what we'll be talking about this afternoon actually comes within. It's also about improving our business environment. And we've had a massive growth in startups in the city region over the last 10 years, which is also one of our strengths. And then it's also about improving the places within the city region. So making sure our towns and high streets are thriving and productive, and that our housing and built environment is also as best as it can be. So that's my role within the city region. And I'm here today to talk about how the local industrial strategy works.
Fantastic. Thanks, Lisa. Jürgen, can you introduce you to the audience, please?
Sure, and thank you very much, James, and an absolute pleasure to be here. Well, you've already introduced a little bit of what my role is today. So I chair the Digital Catapult. The Digital Catapult is part of the whole network of British catapults, and our role is to do two things, and that is one, to help industrial and creative companies to faster adopt digital technologies like augmented reality and virtual reality, and also advanced networking technologies like 5G technology, for example. And the Digital Catapult also works with a lot of startup companies and has a role of nurturing those and helping those startup companies better engage with industry. So that's the role I take there. I'm also very much involved with the Greater Manchester team, and indeed I was party to helping create the Greater Manchester Industrial Strategy. And the real reason why I'm here today and I'm joining this panel is because I have had a passion for many years, which goes back to my long time as working for Siemens in the UK. I was chief executive of the company Siemens in the UK up until last year. And I've always felt that we've underplayed the strength and the capability we have for technology and manufacturing, especially in Greater Manchester and in the northwest of England, but actually it holds true for many British regions. And I think that we need to work much, much harder at creating a really vibrant, strong, new industrial revolution. And many of people call this, of course, the fourth industrial revolution, based on digital technologies, like I was explaining before from the Digital Catapult. And in Manchester, there is this very unique opportunity, which is to create that fourth industrial revolution using digital technologies, and at the same time making that based on advanced materials. So really knitting together the new advanced materials, graphene that we will be talking about during this session, and the fourth industrial revolution, and turning that into an amazing industrial revolution, creating manufacturing based on new advanced materials. And with it, why do we want to do it all? Well, we want to create prosperity. We want to create lots of exciting new manufacturing companies. We want to create lots of new jobs, and we want to export more of that technology from Manchester around the world. Thank you.
Fantastic. Thanks, Jürgen. And then to James Baker, if I could introduce yourself to the audience.
So thanks, James, and everybody. And again, welcome and pleasure to be on this panel this afternoon. So I'm James Baker from the University of Manchester, and I'm the CEO of what we call Graphene at Manchester. So as James said earlier, graphene, 2004, two scientists in the University of Manchester took some sticky tape and some graphite, and you can all do this at home, back in the kitchen on lockdown, so try this out. Take some graphite and some sticky tape and peel that over many, many times, and actually the optimum is about 17 times. And eventually you can isolate a single atomic layer of carbon. So what is graphene? It's a single atomic layer of carbon. It's got length, it's got breadth, but at one atomic layer thick, it's the thinnest possible material. So what? The two scientists who discovered that in 2004 went on to achieve the Nobel Prize for Physics in 2010. But more importantly, around that time, industry started to wonder, how could they use these properties of this 2D material? And you may have heard of some of them, like 200 times stronger than steel, firmly conductive, can act as a perfect membrane to allow some molecules to pass through, but to block others. How could they use that wonder material in their products and applications to create benefit, to create competitive advantage? So what we're going to talk around today is the UK traditionally has had a great reputation for discovery and invention, if you like, discovered in Britain, but it hasn't always had that great reputation for translating that discovered in Britain into made in Britain. And we're going to talk a little bit today is around the Manchester model that brings together the ecosystem, the academics, the supply chain, the large corporations, the small SMEs, the startups. How do we do that in a new and unique way that actually creates value in terms of the creation of products and applications? Fantastic.
Thanks, James. Well, thanks everybody, actually. So maybe just a few questions just to get conversation going. And I might start with Lisa, if I may. So, Lisa, if you were to read the local industry strategy for Greater Manchester, I mean, one thing that is quite salient is that phrase that James has been referring to, and Jürgen, of advanced materials, graphene. Now, if I'm a relatively small business, or even a big business, might be looking at it and thinking, why are you so fascinated with all this? What is this really for me? And why have you put that so embedded in your document?
Okay. So, well, graphene is, it's obviously, it's Nobel Prize winning. It's a revolutionary discovery that's happened here in the city region. It's changed materials science, but it's also one of the most disruptive technologies that has been discovered recently. It's opening up new markets. It's replacing existing technologies. It's changing manufacturing and production processes across multiple industries and sectors. And I think, as you've already mentioned, James, not many people probably think that Greater Manchester still has such a diverse and productive manufacturing base that interacts with global value chains from aerospace and automotive, chemicals, food and drink, paper manufacturing and production. And these are the industries where the applications of graphene really, really have resonance. And we can see that's already starting to take shape. So Greater Manchester is designated as a high potential opportunity area for lightweighting, for example, which is involving lots of our businesses in the manufacturing businesses in the northeast of the city region, and that's gaining international attention. And the opportunities for adapting graphene are pretty limitless, really.
Okay, that's fantastic. Thanks, Lisa. Maybe a question for Jürgen. Jürgen, so if you attend meetings with makers, manufacturers, businesses in well, not even Manchester anyway, really. sometimes you hear the phrase Industry 4.0, and you can see that kind of yeah, maybe. I don't know if you sometimes come across that kind of attitude, but is industrialisation really the next big thing for British or even Manchester industry? You're such a great advocate, so passionate about it, but how do you convince some people that this is the big thing?
Well, what you say is absolutely right. That I speak to numerous manufacturers, and over the last decade, there has been a little bit of, we're not quite sure we're ready for some of the most advanced technologies, such as using advanced data analytics platforms or creating digital twins of manufacturers' production processes. And manufacturers have been saying, just let me sort of catch up on Industry 3.0 first. But I've seen a big change in the last, especially couple of years, because manufacturers are realizing that this is a global race to be competitive. And the fourth industrial revolution and the technologies available are so powerful at being able to improve your productivities, at being able to get your product to market faster, that companies just can't ignore it anymore. And actually, there's been another very interesting fact that has happened during this horrible COVID crisis. But out of all horrible crises, there does come some learning and some lessons. And one of the lessons that has come out of this is that those factories that were better prepared with digital technologies, in other words, those that could model their factories remotely, that could make changes to their factories remotely, that could design a product remotely and get it into a production facility remotely, those companies were better able to manage through the COVID crisis so far. So I'm hopeful that there is an opportunity for that learning of the COVID crisis, together with people realizing that we need to be more globally competitive, for all of that to come together and really help us accelerate this fourth industrial revolution from now on forwards.
Fantastic. So in a way, Jürgen, are you suggesting that COVID is like, you call this the COVID catalyst? This is a driver for change. This is the carrot and the stick combined. It's made people rethink what they're doing.
Yeah, it's shone a light. It's really shone a light on companies that have not invested well enough in this revolution, and actually, we're going to talk a little bit about Made Smarter being a program that helps companies adopt digital technologies, and Made Smarter is getting more calls for help from companies that want to work more remotely, that want to be able to plant their production facilities more remotely. And there's another thing that's really worth mentioning, which is very important for advanced materials. If you go back to previous industrial revolutions, which have all been born on the back of new materials. I mean, obviously you go right back to Manchester and you go to cotton, but the same is true for steel, the same was true for silicon. Something that takes a really long time is to get those materials really working properly within the manufacturing process and within the product that you want to get out. It took ages to get silicon from the point it was discovered through to it being in the first semiconductors. And the beauty of today's digital revolution is you don't have to try all of that physically. You can do a lot of those tests virtually within software systems, and therefore you can go through the cycle of design, build, test without physically building, because you're doing it virtually so much faster. So therefore we've got an opportunity with graphene to use those sorts of digital tools to be able to get graphene products to market much quicker than we did, say, silicon in the last industrial revolution.
Right, okay, thanks. Well, on that point then, I'll take this to James Baker then. So, I mean, your role really is to commercialise graphene and to do some of that work that Jürgen is talking about. You mentioned it's something called the Manchester model, and talk about graphene at Manchester. Could you just expand a little bit on that? What is that proposition?
Sure. So absolutely perfect lead-in from Jürgen's point. Anybody who's studied history of new materials, it can take many tens of years from first invention through to those products being in the marketplace in the form of a product or an application. Silicon's a great example. My background's from aerospace. And again, people may know the first discovery invention of carbon fiber was here in the UK, but the first products of carbon fiber were probably 25 to 30 years before carbon fiber found its way into the supply chain, into products and applications. And even then, it was probably niche products like Formula One, some aerospace products. And although most people who fly, or when you fly again in the near future, hopefully, you'll be flying on a carbon fiber plane, it's now nearly 60 years since that first discovery of carbon fiber through to where we are today of carbon fiber finding its way into the aerospace sector, but still only just finding its way into the automotive or into the energy sector in the form of turbine blades. So what is the Manchester model? For me, very simply, it's building what Jürgen's just said, is how do we challenge, if you like, the whole innovation model of new materials, but find a way of bringing it into manufacturing much quicker than traditionally it's taken us. So in the case of graphene, it's actually only 16 years since that first discovery in 2004 through to today. So 16 years, it's still very young in the time scale. But if we can find a way of accelerating that new material, it will really drive productivity, new products, new applications in the marketplace. So the Manchester model is very much built on the science. So core to what we do at the University of Manchester is research and teaching. And today, it's not just graphene that's been looked at, but a whole family of other two-dimensional materials. So to date, there are over 100 other 2D materials, and the scientists are now building heterostructures or stacks, a bit like Lego bricks of multifunctional materials. So we really are starting to design the future in terms of advanced materials and putting discrimination and functionality into the products that we manufacture. If we can do that, we can really drive productivity and be at the forefront of innovation in terms of new products and applications. But not only do we have the science in Manchester, we also have the National Graphene Institute, a £61 million facility that brings together the scientists from physics, from material science, from engineering, to do that multidisciplinary research, but to do that in a much more aggressive or coordinated way to reduce the time it takes to come from first discovery into producing a lab-based demonstrator or a prototype. We also have the Graphene Engineering Innovation Centre, the GEEK as it's called. And the GEEK is a very new model that's built on the catapults in the UK, but also Fraunhofers in Germany, but also taking tips from DARPA and the US DOD and the Skunk Works that were famous around this rapid prototyping and development. So the GEEK is built on this rapid design, make and validate cycle. And if we can do that in conjunction with modeling, instead of taking months and years to go from an innovation cycle of a new material into a composite or into a rubber or into a battery, and we can do that in a much more rapid make or break type philosophy. So again, from my background in defense, very much driven around a philosophy of rapid prototype, have something that works. If it works, repeat it, spiral development. Or if it's going to fail fast, learn and move on. Why does it take us years or tens of years for an innovation cycle? If we can really challenge that time and do it in a much more concurrent way, maybe in conjunction with digital manufacturing, we can reduce the lead time of a new material from the lab through scale up into manufacturing. So the ecosystem is about working with the academics, but it's working with end users, it's working with large primes. It's also about leveraging the huge capability we have, not just here in Greater Manchester, but across the UK in small and medium enterprises, the SMEs. And it's also about creating startups. So spin outs from university, but not just a startup, but going from a startup to a scale up. So the university is looking at this model, not on its own, but in partnership and collaboration with industry. It's looking to also attract investment and funders. And if we can do that well, we can really accelerate these new products into the marketplace to improve productivity and to improve value.
Oh, okay, so that sounds it sounds like it's the right thing at the right time in a way, which is quite incredible to hear this. If I may, I might take a point with Lisa, and I'm going to look at this in a kind of, so there's James in developing this ecosystem. You have a kind of a role as a regional leader, if I may say. How do you get? I mean, you all three of you here are passionate about what you believe in. You certainly believe in everything you're saying. And how does this translate into those bigger audiences, to civic communities where you're going to Oldham perhaps, or other parts outside Manchester itself? We're talking about Greater Manchester. That's quite a region. How do you go about that, Lisa, to tell that story? What is anything you do that you advise on?
I guess as Greater Manchester, we've got a long history of being an innovative place. So we can point to lots of concrete examples from the past. So, for example, Baby, the first electronic programmable computer, was discovered here. The first railway here. So we can talk about that sort of history and heritage of innovation. But we also have a very strong history of collaboration here. So one of the phrases that Greater Manchester always uses about itself is "we do things differently," and what that really means is we do things in partnership, collaboratively and openly together. And I think that is one of the key ways in which you can take something that's quite complex, like an innovation ecosystem, and explain it to lots of different audiences. So it's how the public sector works with the private sector in the city region. It's how we take those problems that are affecting people and businesses in Greater Manchester and are translating those into innovation challenges and using them to direct where our policy and programs and investment goes.
Brilliant, thank you, Lisa. And Jürgen, if I may, moving from Lisa's points there, from a regional point of view, Manchester does things differently, and it seems that we are. Now, you have a role as a national leader. You sit on, I think, the Industry Strategy Committee as well as the Digital Catapult. You know, your voice that speaks across the nation. Do you feel that what we're doing in Manchester, what's happening in Manchester, can translate to other parts of the UK? Can we start levelling up what's happening in our UK economy for what we're learning here in Manchester?
Well, absolutely. But I mean, the thing that we need to learn from one another, especially, I would say, in regions outside of the southeast, so that's northern regions, but it's also in the southwest. And the thing we should be learning from one another is the process by which we're creating this reindustrialization, the model for catapults, a lot of what James was just talking about. So I think we can learn a lot from one another, and I think we are doing. The issue is I think every region then does have to find its strength. And in Greater Manchester, we found a particular strength in advanced materials and graphene particularly. There's also a strength that Lisa said at the beginning is in health innovation. And you do have to be distinctive in that way. And I think that is the distinctiveness of Greater Manchester. If you go over to the Humber, for example, the distinctiveness there is very much about renewable energy. And in my previous job at Siemens, we were very much part of creating the offshore wind industrial revolution over there. So I think in terms of approach, we need to learn a lot from one another and then find your distinctiveness in terms of especially the innovation and the technology area that you want to focus on.
Right, and this idea, you talk about the Humber, you talk about Manchester, it could be elsewhere. Do you feel post-COVID that supply chains, that we very much were part of a globalisation before we came into this COVID scenario? I feel things are changing now. Will that change? How will that change? Will there be a difference in how we operate?
Yes, is the answer. I mean, actually, there's two factors which are happening, and one is COVID, which is focusing the mind on needing more resilient supply chains. it's going to be focused on a few key areas. For example, there's the classic that we've learned about PPE. There's obviously going to be a focus on having more of your capability to create vaccines and testing facilities for viruses. So there will be that localization agenda. And by the way, there will be graphene-based technologies that help in those, particularly around PPE. For example. However, I wouldn't bet my industrial future on everything becoming local, because the world will get back to normal, and we will rely on global supply chains, and there will be different parts that will be specialist and highly innovative at what they do. And so my view is you cannot never beat innovating and being the best at what you do. And if you do that, then you will export globally. And that's really what our focus is in Manchester. We're not going to rely on the world saying, oh, it's all now going to be local, and lucky you, Manchester, you get a bit more local supply chains. It has to be Manchester innovating and being the best in the world, and that's the best strategy you can take.
Fantastic. Any key markets you've got your eye on there, Jürgen, or we should have our eye on?
Well, I mean, it's got to be truly global, and if you create some of the best technology and some of the best products, certainly things tend to start by looking at your near neighbours. So you work with markets in Europe, and that's not a Brexit point, but you very quickly.
I wondered how long the B word. We've got 30 minutes through, and before we got the B words. That's not bad to go with, I think.
Well, maybe we just leave it at that.
We'll leave it at that. Yeah. It hovers. It's the elephant in the room. Yeah.
But clearly we want to be being truly global in this. So Manchester should be setting its eyes on both exporting but also importing, actually. Because you need to import know-how, and part of your supply chain will also be importing, but you need to net export, and that should be to Asia, to the USA, etc.
Fantastic. Well, James, maybe just, I know the strapline for the conference is getting the next 10 years, right? Hopefully it goes beyond that as well. But in your view, where do you think you'd like to, you've got this model right here now, and it seems to be at the right moment, but where would you like to take that forward? Is there any particular innovations you're looking at, any applications that are very exciting that could be game changers?
I mean, first of all, just build on the previous conversations. For me, this open innovation model is the way forward, with collaboration, partnership, core at that. Also, be careful, in my language, not to be arrogant. It's not all about Manchester. We want to work with the right partners, whether they're in the UK, whether they're international. And just to give one example, in new materials, standards, measurement, characterization is absolutely critical if we want to take a new product to market. And in that area, we're partnered with the National Physical Laboratory, NPL, around standards and measurements. Great capability down in London in the UK. But how do we work with our partners across the UK to create that combined capability? So I think it's really important we don't just think about local, we think about the right partnerships, the right collaborations, wherever they are. Catapults, from Jürgen's point, AMRC in Sheffield around manufacturing. Again, some great examples. And to give you one case study, we work with the AMRC in Sheffield together with the GEEK and the NGI on graphene, but also other universities, UCLan in the Northwest, together with some SMEs to produce a graphene-enhanced aircraft, an unmanned aircraft that flew at the Farnborough Air Show in 2016. So just think of the aerospace industry. If we're going to get aerospace back to where it was, I think it's going to take several years to recover. But if we can accelerate the next generation of lighter, more electric aircraft, lower noise, lower pollution, longer range, less fuel, maybe even vertical takeoff. Graphene and 2D materials, advanced materials and manufacturing hold the real core to, if you like, move into that next generation of more disruptive aircraft. So if I can have a material that was lighter, but also could absorb impact, could also de-ice my wing so I can turn my aircraft around quicker without nasty pollutants, could actually survive a lightning strike, but also could even charge itself as it's flying. That really would start to disrupt, the next generation of the aircraft industry. The one that really excites me probably as much as anything in the graphene space is that around membranes. If you could take a dirty, salty, contaminated water, pass that through a graphene membrane to create drinking water, not only have we got something commercially that would be fantastic in terms of reducing energy, reducing cost of clean water, it would also be huge in terms of transforming water supply, not just for drinking, but for agriculture, for industrial use around the world. So graphene's got this potential, already been shown at very simple 30 centimeter square membranes. But if we can scale that up, and that's where the geek in particular is looking to take that low rate production into sort of scalable by the meter squared of membranes. If we could do that, membranes is an area that could really start to transform, not just commercially, but the way the world secures its water supply for drinking and for agriculture. And they're just two examples. I could also talk about healthcare. I could talk about next generation of supercapacitors. So your car or your bus of the future, working with Lisa and Greater Manchester, if we could make the buses in Manchester have electric engines, but also supercapacitors so they recharge when they're stopping and starting, we can make them even more energy efficient, longer range, lower energy, even more discriminating for Manchester. So lots of area where manufacturing and materials can really make a difference to our everyday lives and towards our targets of achieving carbon neutral by 2038. A huge target if we're going to go and actually achieve some of those really tough targets in the future.
Yeah, that is an ambitious target, I have to be honest. And I'm going to bring in Lisa here because it was your authority, really, that your colleagues that began to set those targets. So James talked about those amazing new products that could be more sustainable aircraft or membranes that can do amazing things in filtration and stuff, and all about sustainability. Now, in your strategy and in your conversations, I've heard you talk about this directing of demand and picking up on this idea of aiming for those big targets. How are they too ambitious? How's that going to work, do you think?
That's a really good question. So our carbon neutrality target is 2038, which is 12 years ahead of the national target. The way that we're trying to manage this ambition is by adopting the mission-based approach, which it has been advocated by the Institute of Public Purpose in UCL. And that involves a number of different strategies for both directing overarching innovation pathways, but also for encouraging as much bottom-up and ground-up innovation as you can. I guess the key components of those at the moment are something called challenge groups. And these are multidisciplinary groups where we've got businesses, scientists, members of the public, charities and third sector organisations, all looking at mini sort of components of that overarching 2038 challenge. And it's through that sort of structure that we're trying to approach that at the moment. I guess one of the key things there really, and it's something that is, I was just reflecting on when James was talking about how do we get the next 10 years right. And for me, at the moment, I'm sort of struggling with the idea of that we've been working from home for so long now, and the lack of contact with colleagues, physical contact. And innovation needs proximity. So whether that is within cities, physical spaces, whether that's connectivity of process through digitalisation, or the ways that we share ideas, I think it's through really creating those settings and those environments where we can have those close and intense interactions with people who think differently to us or come from a different specialism to us, which is how we're going to solve these big problems.
That does sound an exciting idea, actually. Hopefully, yes, hopefully for the university and other venues, we can set those sort of opportunities up. That's fantastic. Jürgen, what's your views on all this? And you've heard from James and that future future of products and where we could be, and then this idea of Lisa of bringing different minds and great minds together into certain places. I mean, how does that excite you?
Well, I think it's all of that, and maybe I just come back to the point of then also setting that really significant challenge of being carbon neutral by 2038. I think challenges like that are absolutely brilliant because they tend to bring out the best in innovators, and everything that we've been talking about in terms of lightweighting to be able to reduce carbon emissions. But then there are other things where graphene is going to be able to help, which is in battery technology to make batteries more efficient, and so therefore energy storage. So you know, I think that combination of a great ecosystem, of good collaboration locally and globally, and then having this incredible challenging target to bring together the best innovators and come up with some really good technology solutions.
Wow. And on top of that, Jürgen, I've got to ask you this now, and pretend James is not here. In your view, what's the most important in all that? Is it your mission to get industries adopted into that digital process? I mean, although Lisa says it's fantastic to have place, we talked about earlier, and the way that helps future-proof some businesses in this crisis was critical. Or should Manchester really drive forward the advanced materials agenda? How would you weight that in your view? Looking as a slight outsider to this, maybe.
Well, the answer is got to be both, hasn't it?
Oh.
Now
you're destined for politics, I can see.
Now, you know, now the sort of the immediate opportunity to improve your productivity and to improve the efficiency in your factory. So that sort of here and now, what can you do today? What can you do next week? What can you do within a few months? That is more in the sort of made smarter, advanced digitalization space. However, you know, my strategies or best strategies are never ones which are in the here and now. You need to do that, and at the same time, you need to have a very clear focus on the long-term future. And I think the long-term future is very much about advanced materials, and then how you can use digital technologies to better design, create, and manufacture technology. So it's the coming together of all of that.
Fantastic. There's been some key themes, I think, throughout this. It's definitely this idea that finding your strength regionally and really focusing on that. Tell your own story and tell it well, but not this. I like this idea that, you know, there's a lot of conversations of localization. But don't be parochial. Engage with the world. Export, import. That seems very important. The notion that we're going to have some really think hard and bringing some fantastic new products to market, and looking at where those markets might be and driving business towards that seems really important. I think what's really come across from all three speakers here is that there's a real optimism, a real positive feeling from what you're saying. I mean, Lisa, I mean, how do you feel? Am I inventing that? Is that a genuine feeling? You are quite optimistic about Manchester or whatever happens next?
Well, I think it was Christopher Freeman who said that innovation tends to surge forwards as crises turn towards recovery, and I think that's the mindset that we have to adopt. Really, I'm not sure there is a choice here.
Okay, a burning bridge. We've just got to go forward. And James, I mean, you've worked a long time in industry as well as serving sort of knowledge hubs like the University of Manchester. What's your feelings? You always seem an optimistic person, but how do you feel about the next few years?
I mean, I'm also upbeat. Clearly, there are going to be industries out there are going to struggle, and there'll be some casualties through that. But just to give one example, 2 weeks ago, I had a LinkedIn message of a fairly small, innovative company who's doing quite well, or was doing quite well before the crisis, but knows it's got to innovate, taking Lisa's point, to survive. So 2 weeks ago, we had the first conversation via LinkedIn. We spoke to them a week ago, had an email this morning. They're about to join The Geek, and we're going to launch a product with them hopefully by Christmas of this year. So there are companies out there, if with the right attitude, the right means, realize they have to innovate to survive. So whilst there'll be some casualties, I'm actually quite upbeat that we are going to learn lessons from what comes out of COVID in terms of productivity, in terms of supply chain, in terms of sustainability. I joke at the moment, my car's currently doing 8 weeks to the gallon because I live in North Wales, but I'm not going anywhere. So people will find innovative and creative ways of doing things in the future that are probably more environmentally sustainable as well. And again, I think graphene and 2D materials can really play into that agenda. So yes, upbeat, but there will be lots of challenges going ahead. And we just need to get going again and start creating value.
James, on that absolute high note, I'm going to bring the panel to a close there, because that's such a positive message there. Colleagues, really grateful for your thoughts there and sharing those your views, and you're being candid today. I've really enjoyed it. I think hopefully the audience has enjoyed it, and yeah, let's keep going. Thank you very much, colleagues.
Thank you.
And I'll hand over to Kat now.
Thank you so much. Absolutely fascinating conversation. I'm actually here in lockdown in Sheffield, and I've worked with Manchester a lot over the years. So all of that was music to my ears, and I'm sure there's a lot to learn from what's going on there. So now we're going to be handing over to the Q&A. Enjoy, and I'll see you for the next session. Welcome back to the Industry 4.0 and Sustainable Supply Chain stage at CogX. I really hope that you enjoyed the last session as much as I did. I am Kat Keeley. I'm the CEO of Beep and the founder of Frontline Live, and I'm going to be your MC for the next couple of days. This next session is called Industry 4.0. What is the impact on sustainability? So any second now, I'm going to hand you over to Alessandra Solberger, who is the founder of Top Tier Impact. She's going to talk about where things are at with manufacturing through the lens of sustainability. What are the opportunities? What are the challenges? Over to you, Alessandra.
Thank you so much, Kat. And hi, everyone. I'm excited to present a panel full of people at the front lines of what's happening in sustainability and in manufacturing. As many of you know, being on this broadcast, a lot is happening, a lot is underway. So we're going to be exploring the challenges, the opportunities, and some other kind of insights from, as I said, the front lines of this. So I'll start with some introduction, and I'll start with myself. I'm Alessandra. I'm the founder of a global network of impact investors, impact entrepreneurs, and corporate leaders, Top Tier Impact. We are across 30 countries. We have over 250 members who are really representing all the areas of impact and sustainability. And so kind of what's happening across their sectors is what we deal with every day and what we see all the time. It's kind of like a pulse that we keep on the state of this global industry. And I think that today, zooming into what's happening with supply chains, with manufacturing, is going to be extremely exciting. I've been seeing a lot in there. So without further ado, we will start with Luc Girardin. Luc, would you like to introduce yourself briefly?
Yes, hello, my name is Luc Girardin. I am a client solution executive at Cognizant. So I basically help our customers build innovative solutions, primarily focusing on artificial intelligence and analytics, but also connecting them with areas like cloud or IoT. And I am also a member of Top Tier Impact.
Thank you so much, Luc. Martina, over to you.
Hi, my name is Martina McPherson. I'm a Senior Vice President for ESG Engagements at Moody's Corporation, and I'm also the President of the Network for Sustainable Financial Markets, an industry and academic think tank for discussing sustainability issues for the next generation.
Thank you, Martina. Wolfgang, over to you.
Yeah, my name is Wolfgang Demacher. I'm a non-executive board member, executive advisor, business angel. I partner with corporates, startups, and asset owners to drive collectively digital transformation. I'm a member of several think tanks for the German government, for SG Innovate in Singapore, because my passion is innovation in supply chains.
Thank you, Wolfgang. Daniel, please introduce yourself. Daniel? So we will move over to Jason.
Hi, it's Jason Mitchell. Thanks, Alessandra, for the opportunity to be on this. So I'm Jason Mitchell. I'm co-head of responsible investment at Man Group. I oversee our approach, strategy, and integration when it comes to ESG and impact across the firm. And I also host a podcast called A Sustainable Future.
Fantastic. We're all about the sustainable future here. Daniel, maybe we can bring you on as well.
Yeah. Hello, can you hear me?
Yes.
Great. So my name's Dan Watson. I'm head of sustainability for Amber Infrastructure. So we invest in infrastructure of the future, and my role is to make sure we're doing that in the right areas. Alongside that role, I'm also board director for the Institute for Corporate Responsibility and Sustainability, and delighted to be here with you all.
Fantastic. Thank you, Dan, and thank you, everybody else. So let's kick things off. First question, just to start diving into the field, is what is the current stand of Industry 4.0, as we call it, and its maturity and adoption level? Wolfgang, would you like to start?
With pleasure, Alexandra. The first thing I would like to to say about that is that Industry 4.0, 4.0 is not a very well-defined term. So it can be a lot of things for different people. I always take a very broad approach and say it's technology which helps to improve and at the end automate industrial processes. And that's where it comes to supply chains. And we all know now during COVID-19 what supply chains are and why they are so important. They are very operational, but when you look at it from a 4.0 point of view, then they become overlaid with more technology, with intelligence. And that means that we are using intelligent assets. We are using trucks and vessels and planes that have a lot of technology and that can connect with other parts along the chain. And by the way, I don't believe that it's a chain. It is a network. It is a system. Because just imagine that in one factory, products are made from a lot of different parts, and they are coming from very different places, and that not in a linear process. So I always talk about a supply network, in fact, which is the ecosystem of Industry 4.0. And it is also not only about supply and e-commerce, because that changed the direction of the flow from a product push to a customer pull. So that means when we talk about Industry 4.0, we are talking about a connected world, a connected industry, a connected economy. And I think that's important when we talk about sustainability, because that can create these butterfly effects, that at one part of the network, something happens, which then ripples across the entire system. So I think that's important to frame our discussion. So where do we stand in terms of adoption, maturity? When approaching that question, we also have to be aware that we have a lot of old assets around, old assets which are still working very well. They're fit for purpose, but they are not intelligent. They are not connected, and are also difficult to retrofit. But there are always ways to work around this. So a lot of discussion about Industry 4.0 is about new means, new processes, new technology, but we have to be mindful about that it's also about old machines and how to retrofit and how to integrate that. And that makes it so hard. So when I was at the World Economic Forum working on the next generation production, we looked into the maturity of Industry 4.0, and we benchmarked Latin America and the Caribbean against developed economies like Japan, like Singapore, South Korea, France, Italy, Germany, the UK, the US. And we did that also to understand what drives 4.0, what drives Industry 4.0. And there are in fact three factors which can help to drive it. And that is how much, the first one is how much are supply chains vertically integrated. So when you have countries which have a lot of steps and cover a lot of steps, are very diversified, they have a higher chance to implement 4.0. Then another one is the competitiveness. The more competitive an industry is, the more you have the chance to drive 4.0. And so just then there are more factors. What also is important in 4.0 is to understand the role of the government. Because when we talk about connectedness and connected systems, they need digital infrastructure, they need communication networks. So if the government doesn't drive the development to connect not only the devices, but the companies, the supply networks, then it's very hard to do. So I'm saying that because some people are quickly to say, okay, this country is, or this company is not very digital, but you have to see the entire context. And what governments can do is to align the policies, the policy framework, the regulatory framework. And if you look into the world, there are very different approaches to it. And the most integrated frameworks are available in Singapore and China with a more top-down approach. And another important thing is the size of a company. So small and mid-sized companies have more difficulties than large ships. And the large companies can help the entire ecosystem to grow. And then I come to the third factor, which I didn't mention before, which is in fact how global is an economy. And the more global it is, the more knowledge it can import, and the more practices, whether it's digital or sustainable. And all that, I hope, explains a bit why I cannot say that is the stage of maturity and that is the stage of adoption. It requires really to go into detail because it is a systemic question.
Fantastic, Wolfgang. Thank you so much for setting the stage. Luke, is there anything else that you'd like to add on this?
Yeah, I think there are factors that also add up to that, which are the human organizational factors. There is also a lot of difference between the industries. You know, if you look at aerospace, they're not going to be at the same stage as, for instance, construction. But I would say many of these industries have an heritage from the second industrial revolution, and now they have to switch to the fourth industrial revolution. So it might be a long step. Along the way of this transformation, there are a couple of factors that prevent them to do that smoothly. Some of them are around their operating model, on their organizational models, you know, which are built for robustness, for scale, on typically models that are very hard to change. You know, you put a bit of rigidity in these models, and that's why it's difficult to change. They are super tankers, not speedboats, many of these companies. Also, I think the personality types that you can find in this type of industry, so people with engineering backgrounds, are again very good for incremental innovation. They are good for efficiency, operational excellence, but it might be more difficult for them to look at, let's say, disruptive transformation of disruptive innovation. As an anecdote, for instance, I'm trying to go sailing with a friend of mine who is an engineer. And the crew is getting a bit too big, so the boat is getting a bit too small. And I told him, why don't you take a bigger boat? And he told me, no, we as engineers, we like to, you know, optimize within our boundaries. So, and he told me, you know, you consultant, you can think out of the box, and you know, you have a constraint, you remove it, and you do something else. But you know, they need a frame somehow. They need a boundary to run and optimize their business. They need this structure. And it's of course very important for the company the way they operate now, in terms of you know, being able to operate effectively at scale. But if you want to change that, it takes a lot of time.
Yes, it's great you mentioned this, Luke, because we all need to try and understand each other's perspectives. And when you're dealing with complex problems, there are a lot of different stakeholders involved. And so trying to make sure that we can put ourselves in each other's shoes is important here. We're going to get to something that is a heated debate in the space, because we currently don't quite have harmonization on impact metrics. At Top Tier Impact, we recently ran a global report on impact metrics for our members. We also polled all our investors across the globe about what metrics they use, what the pros and cons of those are. And then we shared it among us, and unsurprisingly, there are a lot of different approaches in here. And so, Martina, from your perspective, could you please give us an overview of what current measurement systems there are in sustainability today?
Sure, with great pleasure. I mean, I'm looking at it same as you, Alessandra, from an investment and an investor lens. So ultimately, there are the two major areas or pillars, one around normative drivers and the other one around regulatory frameworks. If we are looking at the normative drivers, there are a multitude of frameworks out there linked to assessing in the supply chain oversight and broader S context human rights and labor rights implications. When we look at ILO core standards, ISO principles and classifications, UN Global Compact and UNGP, and the traditional reporting frameworks as put out there by the Global Reporting Initiative and the IRRC. Increasingly, we see also the link back to sustainability accounting, and that's been made on material issues, financial issues by SASB. On the other side, the regulatory drivers here from a European context are up and foremost led by the initiatives of the European Commission. And it has come up most recently with the launch of the Sustainable Finance Action Plan, which includes a green taxonomy, it includes a green bond standard, it includes disclosure for climate-aligned benchmarks, and also for disclosure more broadly of non-financial, I would classify this extra financial information, which is the traditional ESG/sustainability information disclosed by companies. And the current consultation for the latest EU NFRD, the Non-Financial Reporting Directive, is currently out in the market. The plans are to actually get a better picture on what information is disclosed of non-financial information and diversity as it was historically utilized in the context of the regulatory framework, the EU Directive 2014/95. It's interesting there are inherent biases in these regulations, given that the 2014/95 directive applies to companies listed and with more than 500 employees. So there's a huge opportunity, but also a huge challenge to look at the wider sphere when we especially also assess medium-sized to small-sized companies in the wider supply chains of these organizations. A couple of key takeaways ultimately why there are currently these challenges with non-financial information and the inherent biases around reporting. Up and foremost, based on recent studies, companies are reporting at large in a very insufficient and ineffective manner when it comes to specific extra financial factors or criteria, given that there are no common denominators or standards per se. There is a lack of clarification definitions around standards where non-financial performance is ultimately applied. And there is generally a perception around the market failure in corporate disclosure more broadly on sustainability risks and their impacts. And Alessandra, you highlighted on a side note here as well, the different impact classification frameworks. I participated in a study by the UK government-backed initiative for social impact investing, better reporting under the leadership of Paul Druckmann, the former CEO of the IRC. And we looked at 16 different impact classification frameworks and tried to define the common denominators across these ESG and SDG/impact frameworks, and to better understand how these side of criteria could provide a perspective on when and how impact could be assessed. It's becoming clear that it is up and foremost, again, challenging to define the right definitions. It is a challenge to look at implications not only from a sector perspective, as it's done in the context of materiality assessments, but also in a broader regional context. And that, of course, plays a huge importance when we look at impact assessments and the regional context, not only looking at developed versus emerging markets, but also in a country-by-country context. And ultimately, what has become clear out of the most recent discussions around these topics is that there's a need for a more dynamic relationship between materiality and the definitions around materiality, for instance, in the context of double materiality, the externalities of an organization in the context of its activities and how this contributes positively or negatively towards environmental or societal challenges, and the role and the impact the organization has on the wider stakeholder value chain. And there's also ultimately a link back to mandatory reporting standards. they are necessary from a public perspective to gather further information and more clarity and consistency around information, as we had highlighted, but also in the context of the company's own considerations and the understanding of what it defines and how it defines materiality. So ultimately, disclosure on governance and management of organizations, very often the starting point for many ESG assessments in the past, remains key, but also understanding the wider environmental and social impacts of an organization are becoming a prerequisite.
Absolutely. Great points, Martina, in there. Regulation is coming on so many fronts, like the EU legislation coming in. Regional differences also need to be accounted more for because they're substantial. Maybe then, as an infrastructure-focused investor, what would you like to add on this?
Well, firstly, I'd echo all of Martina's points. I think they were excellent. I think from our perspective, even within infrastructure, the amount of different standards and guidance and benchmarks and everything is quite overwhelming, even for someone who spends a lot of time in it. And I think part of the challenge is really trying to understand, which one of these are really valuable to investors and which ones are going to sort of turn the dial. Personally, we've been looking at a number of different ones specific for infrastructure in terms of, SASB, GRESB infrastructure. Then there's also CDP, GRI. There's all the acronyms, and it gets very difficult to work out which one investors value. So when we talk to our investors, quite often they haven't heard of some of these standards. Now, what we are hearing a lot of is investors are very interested to know what the contribution towards the UN Sustainable Development Goals. And what I like about those is that they are, they provide a sort of a global framework for action, but there's actually very little that sits beneath it that is directly relevant to sectors. And so it's very hard to develop anything that potentially is valuable, that investors can compare apples for apples, really. So I think what I would really like to see over time is sort of the convergence of these, and you're starting to see that, in terms of GRESB infrastructure referencing Task Force for Climate-Related Financial Disclosures, which is great, and then you get various points for other standards and climate marks as well. But it really is quite messy and quite difficult for non-technical audience to understand. But what I do like is how organizations are voluntarily pursuing these. And I'm a big fan of sort of self-regulation, because I think industry is the best place to regulate as opposed to being top down. But I do think regulation has a hugely important role to play in providing guidance and a steer. So again, Task Force for Climate-Related Financial Disclosures is a really good one. They've got over 1,000 signatories at the moment. It's voluntary, but in the UK, it's looking that it's going to be mandatory in due course. So I think a blend, but I think everything's moving so fast, it's going to be very difficult for regulation to keep up with pace. So long story short, I think it's just quite complicated.
Indeed, Dan, thank you for that. I think we can all agree. And so let's see how it evolves. But before we move into a different topic, Martina, is there anything else that you would like to add on regulatory frameworks out there and the way that you're seeing them evolving?
Well, one thing maybe to add is that we are seeing global drivers when it comes to up and coming regulatory drivers, and ultimately also the coexistence of many frameworks as well as the alignment of frameworks. I would fully agree with the previous speakers. The sheer number and quantity of these existing normative frameworks is currently overwhelming, but we have seen great initiatives, for instance, by CDSB on better alignment of these sort of reporting frameworks and standards, an initiative and a report that came out last year that actually made the effort to align and look for the common denominators between CDP, TCFD, UN Global Compact, ISO, and other type of normative standards. And as I said and highlighted, now we're seeing in Asia an increasing focus on, for instance, alignment around green bond standards between what we had historically as the People's Bank of China's and NDRC's different type of frameworks that are sitting and coexisting side by side with the climate bonds initiatives, green bond frameworks for labeled green bonds. And hence these type of alignment edition initiatives are now becoming a global phenomena where ultimately there is a lack of global regulation for similar standards or frameworks.
Alessandra, I'd add some stuff to this. Can you hear me?
Right.
Okay, perfect. Yeah, I mean, I guess I'd say that it's very easy to get disheartened by the fact that there is just a tremendous amount of innovation, of frameworks, of standards sort of coming out particularly over the last 5 to 10 years. And even within that, I tend to think of it or conceptualize it as, think of regulation, think of standards, and think of frameworks, and they're all moving at their own cadence, and they're all sort of very specific regionally, i.e., that stack will look very specific in Europe relative to the US, obviously. One thing I would say is, at least going through the pandemic right now, to sort of make this more topical, it's interesting, it's actually fascinating to see sort of the reaction function from certain governments on how to treat this. So for instance, in the US, the reaction function is, let's undo more regulation. So let's deregulate more to help businesses grow through the pandemic crisis. And I give a tremendous amount of credit, as Martina said, to the European Commission, who has, despite there being some obvious delays because of the pandemic, their ambitions remain as committed as they first announced over 1 to 2 years ago with the EU draft regulation. One thing I would note, though, so I'm involved in something called EFRAG. It's the European Financial Reporting Advisory Group, and this is a European Commission steering lab that makes recommendations to the Commission around non-financial and financial reporting standards. And it's, as you've had over the last 2 years, a huge, tremendous effort, as Martina said, around indexes, green bonds, and the taxonomy. I think you've had relatively late in the process this realization by the European Commission, specifically within DG FISMA, but even more broadly that there is an opportunity to drive down, almost as Wolfgang framed it earlier, to sort of drive down this top-down standard in this process. And so what we're doing within EFRAG, earlier this year, Vice President Dombrovskis had mentioned that the European Commission will make an effort to create an ESG standard. Now, they're pretty savvy. They're not naive enough to think that this won't be difficult or fraught with a lot of embedded interests, etc. But what they recognize is that, as you make things more regulatorily and even statutorily rigorous, you have a unique opportunity to converge standards. And so what we're doing right now is going through a mapping exercise, gap analysis, to using a whole bunch of standards and measurement systems out there, SASB, GRI, you name it. And the idea is that Europe has this opportunity to sort of kind of cohere around this. They're not naive enough to think that clearly the US will be part of this, but there are some precedents. For instance, GDPR was an EU initiative, and that has actually been widely adopted by many companies that simply don't want the hassle of managing two standards around privacy. So I do think that there is a big opportunity going forward in terms of what the EU is doing. There are some teething issues. Again, it's sort of interesting to hear Wolfgang discuss this. One of the teething issues is SMEs. So, NFRD, obviously it sort of really focuses on listed companies with more than 500 employees. How do you actually bring smaller SMEs into the fold without making it an exercise solely around resources, or well-resourced compliance and legal department. Because the historical problem with that resourcing element is that you get transparency bias. You get large companies throwing a lot of resources at that, and because of the resources they do, they tend to score very well by rating agencies, MSCI, Sustainalytics, you name it. And it really sort of starts to throw, from an investor perspective, a lot of bias in terms of what you're trying to measure.
Fantastic. Thank you, Jason, for adding these points. And we all want to see some pragmatism as well in these processes. So that's always good news. To dive a little bit more into the investment landscape, still to you, Jason, how are investors changing their approach in manufacturing and in supply chain investments to include sustainability as well? What are you seeing there?
So, I mean, I still think it's very dependent on the industry, and it's still very early, for instance. So we're still kind of coming up the curve in terms of risks, different types of risks. There's some great data sets that are now coming out around physical risk and how you can sort of measure the physical risk across your supply chain. The more complicated, via TCFD is the transition risk and the implications for that. Another risk that we often have to deal with is reputational risk. And you'd be surprised at how problematic this idea is and the kind of data sets that we have to work with. I will just give you one example, because this was a very real one that happened mid last year. There was a mid-cap German chemicals company, very well regarded. It sold chemicals into a Syrian chemical company. Now that Syrian chemical company sold that onto another company that produced sarin gas. And so there was some sort of expose within the news, and suddenly the supply chain was sort of laid bare, and the implication being that this German chemical producer and distributor was sort of at the crosshairs of this. And the implications were significant. So for instance, I mean, we're a fairly large asset manager. We have a 0% tolerance when it comes to controversial arms munitions, including gas. We would have had to sell immediately. And that's true for many other investors. And so I guess my point is we're always trying to sort of understand the risks across supply chains, which are very difficult. One area, when you think about frameworks and what area specifically that needs a lot more work is frameworks that can be used for investors. TCFD, I think, was incredibly impactful because it, in the most unequivocal way, sort of helped converge investors around weighted average carbon intensity, or sort of brought the idea of scenario analysis, despite some of the issues around where you get this data. But it sort of brought this to the fore and created a huge talking point. In many other areas, we're sort of lacking the kind of granular, rigorous framework from an investor perspective to kind of put into place outside of just the scope 1, scope 2, scope 3, obviously a carbon accounting element. It's that area I think needs a lot more maturation in terms of building out that framework. I'm going to pause right there because I know that Daniel had wanted to add some as well.
Yes, absolutely. Dan or Martina, what would you like to say about the changing investment landscape that you see?
Yeah, great. Well, I think from our perspective, we're a bit different, I suppose, because we directly invest in real assets, which gives us a really great insight in many respects. Now, taking the COVID situation, I think it's quite interesting because one of the upsides has been the significant reduction in emissions. So the International Energy Agency estimated around 8%. The downside of that is, we need to do that every year for the next 10 years if we're going to meet the Paris Agreement objectives. We're not even talking about sort of net zero targets here. So lockdown's not going to continue. Factories are going to reopen. So if we're going to have any chance of sort of meeting those targets, there has to be some pretty radical, systematic change. There could be some good behavioural changes that will reduce emissions. So, in terms of working from home, we'll have a big impact on emissions from transport. But fundamentally, our energy, transport, and digital systems aren't fit for purpose. So, as infrastructure investors, we're interested in the building blocks of society, and it's important that we get these right. And as Wolfgang mentioned, if the underlying infrastructure isn't right, the benefits from Industry 4.0 will be limited. From an Amber perspective, how are we changing our approach with sustainability? I guess in many ways we're not. Amber's always sought to make sustainable investments that provide predictable long-term returns. However, we're definitely seeing stronger appetite from sustainable investment from investors. And with the changes needed to transform infrastructure to enable a cleaner society, reduce emissions, cater for changing demographics, the opportunity is greater than ever before. So from our perspective, I suppose there's two ways we look at it. So first off, we can invest in infrastructure that is fundamentally required to drive more sustainable systems. So, for example, if we're going to benefit from Industry 4.0, it needs to be built on rock-solid digital infrastructure. And by that, I mean all the nuts and bolts that you don't see that sit beneath your computer or phone. So decent fibre optic broadband, clean data centres. At the moment in the UK, we're lagging behind other OECD nations, with less than 10% of the population having access to fast broadband. So, we're working with the UK government on the National Digital Infrastructure Fund, which is looking to roll out fibre across the UK to help make the UK more productive and reduce the digital divide. Secondly, at Amber, what we're doing is we're trying to find out how we can manage our assets better in a more sustainable way. So we have a very large asset management team that directly engages with investments on a daily basis. We definitely see an increasing role for technology to help us do this. We manage a large number of social infrastructure investments, for example, and the role of technology to manage the energy of those, we definitely see. But also, we develop these assets from scratch. So, the digitally enabled modern methods of construction is very exciting for us. So we're engaged with Innovate UK to explore that further. I guess we try to approach both the investment, looking at good investments from sustainable are going to support Industry 4.0, and sort of manage our assets in a very progressive way. So we've got a program, Amber Horizons, which we look to integrate emerging and future trends into business decision making. So I suppose this is really important that we get it right, not just because it's the right thing to do, but over the long term, we feel if we can make investments and manage them in a progressive way, they're going to stand the test of time and provide better returns over the long run, really.
Alessandra, do you mind if I just add one more thing? It's
point so that we can stay on track with time.
Oh, sure. Okay, go ahead. So I was just
go for it.
Okay, no, I was just going to say that one thing I think that you're going to see much more in terms of investors appear over the next 12 months is our sort of engagements in stewardship. I mean, we've come into this year and seen some very profound precedents. Barclays Resolution 30 and in response Resolution 29. This climate shareholder proposal put forth by Share Action. It was sort of the first in the UK, which really in some ways was successful. You saw other precedents happen in Japan for the first time ever. I think over the next 12 months, you're going to see that maybe move more on the S side, particularly having gone through the pandemic. And there's going to be a lot of sort of soul searching in terms of what the underemployment or employment issues around sort of the S issue, the ILO issues, sort of zero hours contract or collective bargaining issues are going to sort of come to the fore in terms of supply management. And I suspect, in the next 12 months, in the next AGM season, there are going to be a number of shareholder proposals that look at supply chain and the social element.
Thanks, Jason. Very topical as well to bring this up, given what's happening in the world. So we're going to move to a different topic. Luke, for you and your expertise in this space, what technologies are enabling Industry 4.0 and how are they shaping the new manufacturing and supply chain landscape?
Yeah, I think, when you learned about supply chain 20 or 15 years ago, you were taught that there are basically three flows. One flow is the physical flow, the flow of goods. One flow is the flow of information, and then there is a financial flow. And obviously, the physical flow was really at the center. And we're sort of moving out slowly of this paradigm, where the information flow is getting more and more at the center for different reasons. One reason is to optimize actually the physical flow, so the flow of goods. The other reason is that a lot of business models from this types of company are getting more and more data driven, which means that some companies now are selling data or are selling services relying on data on top of their goods. So if you look at aircraft manufacturers, for instance, like Airbus or Boeing, they build planes, but when they sell a plane, they also sell maintenance services, which is based on thousands of data that they collect from their planes, so their whole fleet. So let's say they build an A350, and they will collect actually a lot of information from all these planes and be able to advise actually the airlines on how to maintain their planes optimally, and therefore help them save money. But that comes also for a fee. So that's why these technologies are now ramping up pretty quickly along with this transformation. And there are three core elements. One is around the data generation. Second one is around data management. And the third one is around data analytics. So basically managing the whole data flow. So data generation in the context of Industry 4.0 is primarily technologies around Internet of Things. This is the core of Industry 4.0 is to connect operating technology with information technology, which was typically separate systems. So you had systems running the machines and then systems running the company. And this is connecting them. So you build data sets that come from your industrial assets. So this is the first technology. And this is moving relatively fast. It was done for many years, putting sensors, using communication devices. But now there are also, let's say, breakthrough around standardization of communication, and also around performance. So the sensors are cheaper, the communication means are also cheaper and more available. The next step to that is 5G, which is going to be a complete game changer also in this area. On the other side of the spectrum, you have analytics, which is often now powered by artificial intelligence. And this is where you gain the value of your data. This is very important in the perspective of sustainability, because this is going to steer actually your flow. On that, depending on the way you're going to build your algorithm, you're going to generate a certain amount of CO2. And currently, the algorithms are mostly looking at optimizing costs, optimizing lead times, optimizing service levels, optimizing risk potentially, but very rarely optimizing the amount of CO2. This is probably the next step in terms of how this technology could be reshuffled. To have algorithm on analytics system who will integrate actually CO2 emission in the equation. And I think that will probably happen when there will be a real dollar price to a ton of CO2, which might come at some point. And then we will really be able to integrate. So right now you can do it with costs that you can get on the market around the ton of CO2. But when company will have to really pay for that, obviously they are going to change also the way they optimize their flow. Or actually, what is also not the big enabler, the big change maker in technology is the whole cloud technology. So it's a major enabler for different reasons. One, because it allows to make more data available. So you have more data sources that you can integrate, which are not only internal data sources from this very large amount of data that actually you could not previously manage on your own infrastructure, or you would need actually supercomputer that very few companies had. But right now, it provides a storage capability, and it allows to bring availability of data amount of data that you could not have before. On the second one is the computational capacity, which is where actually you can also run analytics that are that brings much higher performance on this much larger data set. So a lot of companies are now moving towards cloud for this reason, but also for cost reason, because it's also cheaper. Like mutualizing the infrastructure with other companies. There are also risk elements. There are also cost structure elements, because you basically remove your capex and have much more opex. Financially, it's also interesting for you. And that's why actually right now, even in the COVID situation where most CIO are looking to reduce their costs, cloud is almost untouched. And there are still forecasts of double-digit growth in cloud in the coming years, despite some savings expected by CIO overall in their IT budget. So right now the game is actually to integrate these three elements, which actually come from different players, from the cloud players themselves. So if you look at AWS or Azure, they have obviously AI components, they have IoT components that they can also integrate in their platforms. And it also comes from application vendors like Oracle or Anaplan, who actually now run their application fully on cloud, or manage actually, instead of having data silos that are sort of unmanageable, they put everything on the cloud, and from there they have, after hopefully a bit of time, so some cleaner data sets where they can run relatively clean optimization. There are other technologies that are less in the core. For instance, augmented reality can be interesting, for instance, in warehousing. There are things like drones that are also more and more used. Blockchain is also there. But I would say the core on where right now companies are significantly investing are these three areas, primarily powered by cloud. So it's massive investments. And it's also a competitive race, because companies that will achieve that quicker will I think, gain a very strong competitive advantage in terms of the way they can operate their business more effectively. So in terms of sustainability, of course, all this amount of data is also creating emissions. It's not huge compared to other factors, other areas like energy or transportation, but still it's creating emissions. This being said, I think the gain you get from the optimization, which I explained, so basically this data allows you actually to save CO2. So you create a little bit of emissions from storing this data, but it's basically to help running your business in a way that can be more sustainable. But of course, that requires a change of mindset from companies to change their objectives into let's say a stakeholder view, where they will not only look at financial returns, but they will look at the overall impact that they get on the society, on the environment.
Thank you so much, Luc. That was a very comprehensive overview. Wolfgang, is there anything else that you'd like to add in terms of the sustainability challenges that all of this transition is bringing up?
As in many parts of life, opportunities come with challenges, and challenges bring opportunities. So I would like to build on what I said before. I think what is the major opportunity and the major challenge at the same time is this connected world. If we get it wrong, we will get it terribly wrong. And in the digital age, everything goes faster. So if we get it right, we can correct things which we have done wrong over many years in a shorter period of time. That's my real macro answer. Then when I listen to the conversation, I remind myself that sustainability can also be defined in different ways. It is, in fact, at least a three-dimensional thing. It is economic sustainability, it is environmental sustainability, and it is social sustainability. It's about ecological, ethical, and environmental health. And then when I think about challenges and opportunities, there is the supranational level, the national level, and the business level. There's more, but these are big clusters. And when you look at the supranational layer, and we just acknowledge that 50% of trade is attributed to digital, of goods trade is already attributed to digital trade. We need to factor that in. And I'm not sure whether we have factored that in. We also have to be mindful of the world we are living. We are living in a world which is driving at high speed towards digitization, which is all about technology and all about standards at the end of the day. And we are creating two universes of standards. One is US-centered and the other is China-centered. So on the supranational level, if we talk about 4.0, there are challenges and there is need for alignment, also because data has no passport, no commercial invoice, etc. So when you look at the national level, you also want to look at your health, right? At the people's health. So what is the impact of 4.0 on health, on people working more from home? It can be good, it can be less good. We have to work this out. When I think about the economy, the digital economy, and I hear all this and look at it, and rightly so, it is probably easier to fix. But we always think that digital is good because it has no emissions, but the digital economy is emitting as much as the aviation industry. And that industry is growing very, very fast. So another area to look at the national level. And yes, I mentioned this comprehensive policy framework. So we have probably a risk of losing some on the bandwagon because their systems don't allow to harmonize policies across sectors, from logistics to telecommunication, to manufacturing, etc., to retail. And you need that because you need this flow, so that there are challenges there in the policy framework, especially in countries which build them bottom up. These are only a few. There is the challenge I mentioned before on the SMEs. We might create more and more big data-driven companies. And we have touched upon that point several times. But I also see a very, very big opportunity, and this is in building the circular economy. So in a much more connected world, if we push the right button, if we optimize our system, if we use the connectiveness or the connectivity to drive innovation in the right way, it can be fantastic. And of course, capital has to follow.
Alessandra, I think you're on mute.
Guys, thank you for this. I kept unmuting myself and I knew this was going to happen at some point. What I was saying is that Wolfgang's conclusion here was really good because there are so many different levels, so many different dimensions that we need to keep into account for painting a picture of reality that is accurate enough for us to make decisions on. And we see that top-tier impact where we have working groups across all of these different topics where members debate, have calls, like discuss working groups like CO2 emissions, circular economy, green infrastructure, impact metrics, regenerative systems. And when you abstract, because we synthesize this information to see the patterns, you start seeing like very interesting commonalities at times, and sometimes not. Sometimes you need to connect the dots. So on this note, we will move into our Q&A. There are various questions that have come through from the audience. We will start with Anne-France, who is asking, can you define sustainability, i.e., how do you comprehend the potential conflicts between the 17 different SDGs? Who would like to take this?
So I can have a go at it. At Amber, we've developed an internal framework where we look to separate impact against the UN SDGs versus what aspects need to be managed to ensure that impact doesn't negatively impact on other things. So say, for example, our investments in railway, we see them having a big impact on UN SDG 9 and 11, providing sustainable transport. But if you were to look at it in itself, if we were to make investments in rail transport that were all diesel, had a terrible health and safety record, it's not really a sustainable investment. So for us, we try and separate it out into the two. So for every benefit that we're attributing to UN SDGs, we then looking to balance it with what needs to be managed. So sort of a bit of a balance sheet, I suppose. And there are some tools which are becoming available to help that sort of SDG balance sheet. But I think they're very good, but the challenge is with the sort of the balance sheet approach to UN Sustainable Development Goals, in my view, is ultimately it comes to a bit of an ethical decision in terms of, well, what's more important than the other? Is having impact on climate change more important than impact on jobs and whatnot? So I think that's challenging, but that's, going to Jason's point, that's what I find quite positive around the EU taxonomy, in that it outlines that, to be a sustainable investment, you need to make sure that you're not negatively impacting on a whole suite of other metrics which they've identified.
Fantastic. Thanks, Dan.
Alessandra, if I may. Yeah.
Sorry, yeah, Martina, we are actually going to continue this full Q&A with the various questions that have come up in the Q&A stage. So at this point, we will wrap up on this stage. We will move there. Thank you guys so much for sharing all of these insights very generously and also in a comprehensive way. This is really appreciated because, like we said before, reality is a very complex picture right now, and we need to reconcile it on an ongoing way and in a committed way. So thank you for showing up like this, and I look forward to continuing in the Q&A area with all the others that will join us there.
Thank you so much, Alexandra, and your inspiring, knowledgeable panel. Absolutely fantastic conversation. There can be nothing more important than the conversation we've just heard. I am a techno-utopian, but we've got so much to learn to figure out how we can get the full potential from technology, how technology can impact manufacturing, and how data can power sustainable improvements and behavior change. And now is the time. My truth is that doing good is good business. If success is not sustainable, then it isn't really success. So with that, I'm going to hand you back over to the Q&A, and I'll see you back soon. Welcome back to the Industry 4.0 and Sustainable Supply Chain stage here at CogX. I'm hoping that you've enjoyed the session so far as much as I have. I am Kat Keeley. I am CEO of Beep and founder of Frontline Live, and I'm here as your MC for the next couple of days. The next session is called Combating COVID-19 Impacts and the Competitive Advantage. And soon I will be handing you over to Gabriela Ducasse, Director of Marketing and Business Development, and Jamie Devlin, MD of Illusions, Inc. People have been talking a lot about digital transformation, and there's a lot of interest and confusion and memes. But what's myth and what's reality around how AI can actually help us out of this the crisis that is COVID? Over to Gabriela and Jamie.
Hi, everyone. Thank you so much for joining us today. We're really excited to get started with you guys and go straight into our slides. So a little bit about myself, Gabriela Ducasse. I started my career in tech at Oracle a few years ago, but I really wanted to join a team that was actually delivering real results in real time. So I started with Illusions about 3 years ago. And it's been great ever since. I've been working hand in hand with Jamie Devlin, who's a great coworker, and I'd like to hand it off to him.
Thanks, Gabriela. Good afternoon, everybody, or good morning, wherever you are signing in from around the world today. I'm Managing Director of Illusions, looking after our clients across the EMEA region and beyond. And my career has been in a combination of business consultancy and technology. I think I was working on some big data analytics projects 20 years ago, but now, and particularly now, I think the work we've been doing with Illusions in the past few years around AI and actually having a meaningful impact on our clients' value chain, delivering some very tangible benefits, making sense of AI, what it means in practice, and how it can actually help deliver an immediate benefit to organizations as they react to the challenges of COVID and as their business evolves through the other side. It becomes very, very important. So we're really looking forward to sharing our thoughts with you today on how that can be achieved and ultimately how organizations can actually gain a competitive advantage as we meet and beat the challenges that have been brought to us by COVID-19.
Great. Yeah, that's so true, Jamie, everything you said. We see here that everybody has really been talking about the impacts of COVID-19, but my question really to you, Jamie, is what are some of these impacts? Like, what are we seeing actual clients talking about?
I think most of all, the biggest impact we've seen is really people are reacting to the unknown. So for all the business continuity programs, for all the plan Bs and plan Cs are in place, none of them, or very, very, very few of them, will be able to address the challenges that COVID has brought to the global economy and to companies and organizations in every different sector. If you think about how it affects us on a personal level, it absolutely then reads across into how we interact with each other across society, and then across how companies interact with each other as well. So if you think about the whole value chain of an organization or a company, everything from forecasting demand, whether that's customer demand or production demand or users or whatever that may be, that's been thrown into chaos. There's a huge amount of volatility in pretty much every single market. Our clients that we work with in the manufacturing or chemical processing industry, oil and gas industries, have suddenly either seen a massive drop in demand they're having to react to, or actually what's interesting with some of them, they saw what we call a super cycle of demand at the start of COVID, where companies that were producing ingredients that go into hand sanitizers or PPE equipment or the products we were all buying in supermarkets at crazy levels, they saw a super cycle of demand. But now, because there's so much out there in the market and storage is now becoming an issue, they're seeing a very low demand. So we're seeing ultimately a very high level of volatility in demand, and that then impacts the rest of the process, from sourcing ingredients and from sourcing raw materials, from sourcing feedstock. Again, high levels of volatility around cost of those resources. And when it comes to actually the production process or manufacturing process or refining process itself, we're seeing then a lot of issues around being able to configure your processes to actually meet that new level of demand, ultimately then with a fluctuating workforce. And many of the organizations we work with have seen a huge drop in the amount of people, one, that are available to work, maybe because of COVID directly, or because they are scaling back to ensure that their workforce is protected. And that has a follow-on impact then in how they approach the market and logistics. We've all seen the issues with air transport and road logistics. So the whole value chain, pretty much for every industry you can think of, is impacted at some level across those areas that I've talked about. And I think Illusions being at the heart of what we do as a business is deliver end-to-end artificial intelligence across those type of processes I've just described through our Maestro AI platform. And I think what we've seen is those organizations that have a digital strategy in place that can replace manual processes and work where possible, that can forecast and respond to volatility and demand the best. They're the companies that are both weathering the storm and also positioning themselves to gain that competitive advantage when the storm passes and we return to some kind of normality. So I think that's interesting. I think that what we're going to come on to now, Gabriella, maybe is to look at actually what have people been talking about AI and digitalization in this context. And there's some really interesting statistics from the research that you've carried out.
Yeah, I think that's a great segue, because we've noticed that so many more people, there's so many more conversations online, whether it's on Twitter and blogs or on people's websites, LinkedIn, every channel, people are just talking about artificial intelligence, automation, machine learning, digital, and especially as a way to combat COVID-19. We've seen these conversations jump by 17% since December of last year. Of course, in January 2020, people were all setting up to, gear up for AI in this year and this decade and really looking to it. But now more than ever, we're seeing that people want to talk about artificial intelligence. But people are talking about it, but what exactly are they saying and why is it relevant right now?
Yeah, you're absolutely right. I think there was, I read a report actually, it may have come from McKinsey or elsewhere, but in 2017, it's estimated that 375 million workers, or potentially 14% of the global workforce, would be requiring to change jobs or change skills to respond to the changing working environment, whether that's driven by AI, automation, or elsewhere. Some people say, think about the jobs people were doing 100 or 150 years ago, and how many of those jobs still exist now. So there's a sense that there's inevitability, I think, around how the workforce changes and the skills that are required and the technologies that are available. But I think what we've seen now is an acceleration of that thinking in response to COVID. In particular, people have a reason now to rethink that. And interestingly, I think it was a couple of years ago, and this was from a McKinsey report, 87% of executives said they did have a skills gap. So there is a skills gap for people to fill, but 50% of those executives didn't know how to fill it. And I think COVID has accelerated that whole process.
Definitely, I totally agree. And just to move forward, I think we can see that these are some of the key terms that are being talked about online regarding artificial intelligence and the surrounding words and COVID-19. Obviously, COVID-19 is huge. People are looking to AI not only to solve and to find a cure or a vaccine for COVID-19, but also to, like we're saying, address the business impacts and the global impacts of what's happened. It's such an unprecedented event, and AI is really being sought after as a solution.
Yeah, I think some of these words are actually really interesting. and you're cautious about joining them up a bit too much on these kind of charts, but I have some in front of me here. But business, data, artificial intelligence is definitely in there. Challenges is big in there as well. Technology, one of the biggest words. I think services, cloud, analytics, accelerate. There's some absolute key words in there. I think it's interesting to see how they put that together. What does it mean? Maybe it's symptomatic of what we said up front, Gabriella, about people knowing there has to be something in these solutions, in these words people are using, but what does it actually mean in practice, and how can we do it?
Definitely. And you see here, there's people are talking about the future and how to move forward and how do we get beyond this. And we can't really afford to be looking at all of the noise. We need to really be talking about AI as something that's well-defined and applicable with tangible and verifiable outcomes. And I really think that is one of the key differentiators between Illusions and a lot of other people who are talking about AI online. We're talking about tangible results, how to get past COVID, and that's what we're here to talk about today.
I think so. I think one of the biggest challenges we find in companies that we work with who want to, they know there's a benefit that can be delivered through AI. They're not sure what that benefit is, and they're not sure how to get there. And people have had huge challenges around issues such as data collection, data cleansing, people building data lakes. With an Illusions approach, with Maestro, our AI platform, where we don't need those things. And I think the key to being able to deliver that benefit immediately and sustain it is the neural network that we've developed in Maestro that automates and completely autonomously optimizes these processes. That self-learning ability of a neural network has been key for us accelerating those benefits with clients, even in normal times. And now that's become just even more compelling as a way through COVID. So yeah, let's get on and talk about some of those things.
Yes, let's. Okay. So here we are. Adapt quickly and thrive. That's really what we believe, right?
Yeah, I think so. And that's the important piece. And I think these three areas that we're going to talk about in a little bit more detail are also really important. And that really grounds AI and what you can deliver with AI in reality. It's really important, first and foremost, that companies and organizations can stabilize as a result of COVID and those challenges that we discussed earlier. So first and foremost, can they survive? Can they stabilize this huge amount of volatility that's occurring across their value chain and within their own organization at all levels, leadership levels, operational levels, middle management levels, across their contractors, across their logistics arms, across their supply chain. So there's a need to bring some stability to the process. And then we're going to come on and talk about, okay, once you're stable and you've settled the ship, you've steadied the ship, how can you then optimize? How can you deliver much needed cost savings? How can you increase margins at a time when there's lots of money being thrown around and there's very little, often much less revenue coming in? So how can we actually optimize the performance of these companies at the time? And then what opportunity does that actually give us for the future? And if you are using AI to stabilize and optimize your organization right now, what does it mean for transforming your business in the long term? What does it mean for your operating models and your organizational structure? What does it mean for your existing infrastructure and ways of working? And people are, thinking about a new normality, and this could be the trigger to do that and accelerate it. And I think, to touch on Illusions and Maestro a little bit more, that's, as I say, what we've been doing for the last 25 years, and particularly around AI in the last 7 to 10 years. But it really is that ability to implement Maestro within an environment in a very non-intrusive way. So without having to spend months or weeks on end working with clients to map their processes and develop algorithms and obtain all that domain knowledge from the organization, a client organization, which takes up a lot of time, and they just can't afford that time right now.
Yeah.
So with Maestro, what we've seen by deploying it in those client infrastructures and connecting to existing systems, and Maestro is actually autonomously learning those client processes. It's understanding the impacts across the whole value chain, and it's identifying crucially where those opportunities lie to optimize. And that's what we're seeing now. The application of that approach, which we do normally in any case, but the application of that approach now it is even more compelling because of those challenges that COVID's brought. So I think that's the context in which I think looking at the challenges, looking at we say noise, it's not necessarily noise. There's a lot of people talking about it, which is great, but articulate it in a way for their organization that makes sense, and there's a clear benefit, and there's a clear path to achieving those objectives. I think that's the biggest challenge of all that these organizations are facing.
Yeah, I think you could say that there's a lot more on the line right now, given everything that's happened. And I think we all would like to believe that we're kind of at this midpoint or a little bit farther in, but it's such an unprecedented time that we don't really know. Are we still at the beginning? Are we in the middle? Are we towards the end? It's really a lot of unknowns. And I guess my question to you, basically, because of all the interaction that you've had with clients, is where do you think most companies are? Are they stabilizing? Are they stabilized? Are they optimizing? Where are they?
I think it's a bit of both, and they're stabilizing for different reasons. Some of them are having to respond to very high levels of demand actually at the start of COVID, which brought its own challenges, and being able to meet those. And those clients that were in industries which took an immediate hit on demand. And once you get past that kind of period of what on earth is going on here, I think those people, particularly at leadership level in those organizations, that can set the strategy as quickly as possible, and then look for, okay, well, how do we deliver on that? How can we take an oil refinery that's now operating at 60% capacity and reconfigure our refining assets to meet that capacity and still deliver the operating margins that we're looking for with a reduced workforce and different shift patterns? So I think it's interesting. I think there's a couple of angles to look at this actually. Some organizations kind of bunker in, pull the shutters down, let's get our heads down, let's focus on our core business and see if we can get through this. And I think other organizations, and maybe this is around digital, but it's also other aspects as well, say, okay, we're going to have to think differently. And we're going to have to think differently now. We can't afford to do it when we think we're stable, because as you said, Gabriella, what does being stable mean? What do we think the economy is going to look like? I mean, look at airlines, look at airports that are literally have no passengers, whereas previously they're looking at millions of passengers every quarter. How on earth do these organizations actually respond to those challenges? So I think it's to think you're stable now is risky to some extent, because we simply don't know how the next weeks and months are going to pan out. So being prepared at every level is so important.
I totally agree. I think we should dive a little bit deeper into each step, and let's talk a little bit more about stabilizing survival. I mean, airlines, it's a great example. People are just starting to move around a little bit more now, and it's easy. Yeah. It's easy for us to say, oh, you need to deploy at speed and scale, but how is Aleutians actually doing it?
Yeah, I think I mentioned it a couple of times, and sometimes when people talk about data collection and cleaning data and what have you, it seems like the boring part of AI. But I'm sure as everyone who's listening to this talk this afternoon and this week at CogX knows, data acquisition, data handling, data processing is very obviously at the heart of a successful approach to AI and its application across not just an organization, but across that organization's value chain. And I think one of the key things that we've done at Solutions to enable that to happen very quickly is automating that entire process. So connecting to our clients' existing infrastructure has been absolutely key. So we don't have to install new equipment or rip and replace anything that's there. We can sit and interconnect with our clients' control systems and ERP systems and maintenance systems and supply systems and customer data, and that all comes into Maestro, and we automate that whole process. And Maestro can handle that different formats, different timestamps, different protocols, filling data gaps, cleansing tags and control systems that would otherwise take weeks and weeks. And that means once we process that data very quickly through Maestro, we're able to demonstrate to the client exactly where we see those opportunities to optimize their value chain. And that's the really important part. As you said right up front, Gabriella, people don't want to be distracted at these sort of times by projects that may or may not deliver a benefit. This is something new, this sounds disruptive. And to an extent, they're right, innovation is disruptive. But if you have a clear path forward, and if you're confident of the benefits it's going to deliver, then it's worth it. And I think that's the key part, being confident in the benefit it's going to deliver. And I think what we see with our clients, when we process that data through Maestro and we show them that this is exactly what Maestro is now going to do, it's going to optimize this part of your production process, this part of your sourcing strategy or trading strategy, your customer demand forecasting, and we can show them with very clear examples how that would happen, then it gives that senior leadership team the confidence to actually go ahead and do it. And for us, being outcome focused is absolutely crucial, particularly in the space of AI, when there is so-called sort of noise around, and well, how much benefit is Maestro delivering compared to what we could do with our own people, our own experts? And that's about us proving that in that environment, in a live environment with real examples, and show how the interdependency of all those variables and constraints, the physical constraints, the data constraints, how they do actually interact with each other to find benefits that could not otherwise be found by humans, simply in terms of processing capacity, but also what I would call standard algorithmic capabilities. So we definitely want to move away from individual or kind of teams of data scientists coding very specific algorithms through to Maestro, which is an autonomous neural network, which is self-generating algorithms to optimize that entire process. That's how you deploy quickly. And while we could talk for hours about the technology, which I think is really cool, the outcome is so important.
Yeah, and I think that's a great.
I know you're moving me on.
Yeah, I'm going to move you on because you hit this one really. You talked about optimization, and we can just briefly go over this one. And you already hit my questions on tangible outcomes and how are we really seeing this happen. So, Solutions is leading that.
Yeah, I think we did touch on a bit. I think by tangible outcomes, let's also be clear, what we mean by that. This isn't saying, a big kind of finger in the air. We think we saved, we've reduced the unit cost of production by a few percent, and we've increased revenue by this amount. And this is actually every single decision that Maestro has made for that organization, being able to track it back to a very precise increase in production value or a reduction in operational cost that can be verified, it can be audited, so that people have a very high level of confidence in the impact that we're having, which, by the way, is also an automated aspect of Maestro. We're very outcome focused. We depend and we focus entirely on the outcome that we deliver. So for Maestro to be able to measure that benefit in real time, and let our clients see that benefit accrue in real time, is very, very important. So it has to be very tangible. That's not a throwaway statement. It has to be very, very clear. And that's where people see the incremental benefit of AI as opposed to other projects that are going on as well. So we're moving away. This isn't dashboarding. This isn't providing information in a way that enables people to make better decisions. This is actually prescribing the decisions and actions that control systems or people need to take to actually deliver that benefit that Maestro has identified.
Yeah, you're talking about true artificial intelligence leading to this optimization, which in the end will lead to transformation, which I think brings us nicely to our next point. And
there you go. Almost like we planned. Yeah,
it's almost, I mean, really. So, Jamie,
very serious. I need to smile more. I think I was a bit serious after that. Yeah.
How are these benefits that we're talking about, tangible results, using real artificial intelligence? You know, that's something really important for us, a big differentiator with Elutions. We're talking about true artificial intelligence. How are these benefits sustained long term?
It's a great question. And very often, and I've been in the organizations I've worked with in my over my career, you do a great project. Wow, look what we've achieved. And then unless you embed that in the organization, it goes on a shelf. You might even have an award. The award collects dust, and you haven't sustained those benefits in the long term. So I think and particularly in our experience of AI and the approach I've just described, by definition, we are really embedding AI into that client's value chain and their processes. So let's assume we are delivering the benefits that we identify, and they're very tangible. And it's the leadership, and I talk about the senior leadership team because very often you do need senior level sponsorship for these type of programs, because it is changing the organization, and senior level sponsorship, I think, is very important from a strategy perspective, and then working with teams across the organization to actually implement that strategy. But it transforms the operating models for sure. The old ways of working, which still may be there fundamentally. We're not changing the design principles necessarily of a chemical process or a refinery, although we are to some extent. But we are looking to embed that as continuous improvement. These environments people operate in are dynamic. Things are changing all the time. And that's where autonomous AI responds to those dynamic environments in real time and without bias. So we don't have cognitive bias going into those decision makings. It's driven by the data across billions of data points to make those benefits a reality and transform for long term. The ultimate transformation through AI could potentially be a manufacturing company taking a different position in the market, moving into different areas. There's a real opportunity for companies to maybe diversify as a result of AI across their value chain and what it tells them about where their strengths and weaknesses are in their current operating models, or indeed the profitability of the products that they're making. We're working on that with some organizations as well in manufacturing and food and beverage manufacturing, which products that we think are profitable, and what is the actual unit cost of making them compared to demand, and can we forecast that accurately? And these type of correlations are just so difficult unless you have really powerful AI platforms. So I think transformation is an inevitable consequence of deploying this type of AI, but it can be so much more if it's really embraced by the whole organization.
And I think what you're alluding to, really the ultimate transformation, we're kind of getting into the competitive advantage, right?
Exactly. And that could be a competitive advantage simply because you've been able to survive and stabilize and optimize as a result of COVID. That could be your competitive advantage. But much more strategically than that, I think there's that opportunity for organizations. I say organization, not just companies. Clearly there are companies that we work with that are for profit and looking to survive in a globalized market. But there's also organizations in many different sectors of our society that could also benefit from this, particularly those that are engaging with millions of people on a day-to-day basis. But really that's at the core of Elutions' philosophy to AI. There has to be a point. What is the point of doing this? There's no point to do it if you cannot see a benefit, if it's not going to change your organization, if you go back to old ways of working. But there is absolutely a point if at the end of as a result of implementing Maestro and the sort of approach to AI that I've described, that it not only changes what you're doing and saves money and increases your margins in the short and medium term, but what does it mean for your business in the long term? And what does your business mean in the next 25, 30 years? As I said right at the start, you think about companies that exist today and how long they've been in business and how many of them are older than 50, 60, 70 years old. Not many at all.
Right. That's
so
true.
For companies to sustain in the long term, by definition, you need competitive advantage, you need to survive, and AI can give you a really powerful and different perspective on where that journey should take you.
Yeah, totally agree. It was great to chat with you today, Jamie.
Thanks, Gabriella. Good to talk to you in this kind of context.
Yeah.
I hope it's been informative, maybe thought-provoking, purposefully so for the people listening, and we'd be happy to take some questions.
Definitely.
Bang on time. How about that?
Thank you so much for that thought-provoking session, Gabriella and Jamie. There is so many uncertainties and so much noise. We're all bombarded by these endless challenges that are constantly reported. And people need some way of understanding the accelerating change. We need some sense of stability, of clarity. We need to see opportunities. We need support to make the right decisions. And it occurred to me as I was listening to that maybe it's the lack of human leadership that is driving people to look to AI for some common sense. And now it's time to hand over to the Q&A, and I'll see you back here at the Industry 4.0 and Sustainable Supply Chain stage here at CogX. Our first session is at 10 a.m, where we'll be looking at where are we now? How will COVID-19 impact the next phase of the Industry 4.0 revolution? Can industry adapt business models quickly enough to recover? So I look forward to seeing you then.